Hello, hello. Welcome to the stream. About to start. Just give me a moment getting ready. Uh, Hope you're doing good. Um, Last week I was traveling. I was in Hamburg at Code Talks doing a talk about procedural generation in my games. So that is why I was absent for like 2 weeks, basically, not streaming, because I was preparing my talk, and I'm happy to say that it went well. That people were excited about it. Had a lot of questions after it, and it will be online at some point in the future. I'm not exactly sure when, but they will tell us. Um, yeah. So let me just get ready. Okay. So let's see. Yes, code is there. Yeah, I'm gonna start a new project. So, okay, I'm ready to start. Did I share? Yes, I did. Um, okay, cool. Let's begin. Uh, Hello everyone. Uh, I'm intending to continue from where I left off on my last Zig stream, but there's a little bit of a difference from the last time I was around. You may notice my environment is a little bit different because I'm not actually on my own laptop. Uh, I've I've lost a power supply for my laptop, so I'm now on a borrowed laptop from my friend right now. So I don't actually have stuff that I was doing last time, but I wanted to stream. So So I've just rewritten the stream, the previous stream I had. This was actually from the stream 2. Let's just put it like stream 2. And yeah, I intended to go on my last stream. I was intending to do all the stuff, but I stopped somewhere in the middle, and I wanted to show a few more cool Zig features. So instead of focusing on yeah, stuff that I was doing the previous, like doing working on my C++ engine, I decided to instead do a Zig stream today because yeah, I actually wanted to make I wanted to continue working on my engine and on Shakedown. But since my PC is right now out of order, I am continuing the search for my power supply tomorrow. So hopefully tomorrow I will have it. But today is a little bit of a temporary, Zig setup, let's say. Okay, so where did we leave off? We left off on my last stream. I showed how AnyType works, inline 4 and CompTime, which are all part of the compile time execution of the code, because any type can be inferred into its own type. That's how you can create functions that can take like any type of integer into like an add function or something. Because AnyType is basically creates instances of different functions at compile time. And then inline 4 can be used to get information of type at runtime. Sorry, not at runtime, but at compile time, to create different functions, instances of different functions. And CompTime can be used for, of course, passing in different types and basically generics. So this is all kind of mechanisms for doing compile time stuff. And then I showed a little bit of packed structs, which I did with bools. Oh, by the way, the previous stream you can find on YouTube now. So if you search for YouTube Notke, you can find the previous 2 Zig streams that I did. And yeah, and it's all there. I'm just like retelling now what I did in the previous one. So yeah, packed structs. You can turn bools, which can turn bools from bytes into individual bits. And when you set individual bits, you're basically just using flag bit casts, right? And flag, how to say, like bit operations, right? The compiler does it for you, but you just need to like set true and false. And also together with that goes arbitrary sized ints, which when you pack, they will not have any padding in between them, which is pretty cool. So today I want to talk about some, how do you call it? Oh yeah, like control loop operations, like whiles, fors, and what else is there? Oh yeah, and ifs, of course. But yeah, because if is not a loop, but it does feature captures. So the 2 bars, vertical bars in Zig, are actually captures. And yeah, let me actually show you. I'm gonna create a new Zig project, okay, for this time, because I don't have my old one. I didn't I didn't make a Git repository, unfortunately. But I will combine the 2 repositories for a future build once I get my computer. So I'm gonna call this a Zig, I don't know, how did I call it? Zig features. Zig features preview or something like that. How did I actually call this? okay, let's call it cool Zig features. Something like this. Okay, cool Zig features. And what I'm going to do is I'm going to start a terminal, and I'm going to say zig init exit. And what this does is that it creates a Zig project. So now when I open it with code, that is, by the way, that the Zig toolchain does all this for you. So one executable, one application, and it does everything for you. So it has created a build file, and it has created a main.zig. And the build file basically links and says what needs to be compiled, which source files, and how do we actually what do we compile into. In this case, because we made an exe, it's going to compile into an exe, and it's going to use default target and optimization. By default target, it means my machine, which in this case is Windows, and optimize is by default it's going to use a debug, and then it creates an artifact, which is the exit, and then basically run the compiler. Oh no, this is the run. This is the run step. Yeah. So if you call a run, it will actually run the exit, and then finally we have some tests here, which actually don't exist, or do they? Oh no, there is actually one simple test. So what you can do here with this, when you create a project, you can start a terminal and just say zig build run, and when I do this, it will build the project and then run it, and by running, there it is, it says all your code bases belong to us, and says run the test to run all the tests, which I'm not going to do. But if you would say zig build test, then it would run the tests, and because all the tests pass, nothing happens. If we had some mistake here, it would crash and would say, oh, there is an error while testing. By the way, does my audio work? It does. Okay, good. I hope it works, by the way. Tell me if it doesn't. Okay, so, and what we can also see is that Zig has created two folders here. Zig cache, where it puts all the object files, header files, and oh, this is not the header file. This is works fine, sir. Yeah. Hello, Night Camper. So this is all the STD stuff. I see. So it creates all. I guess these are kind of like headers, and then object files, and finally it uses it to build the binary, which is here, right? And the PDB, which is used for debugging. So that is how you build your that is how you can create your super simple Zig application. But for now, I'm gonna delete everything except my void, right? This is the starting point. And let's just make a little test by having a little log info. I can do a little does it work? And then do a Zig build test, and not test, run. Yeah, does it work? It does work, and as you can see, it has basically, like the compiler is actually pretty fast, right? When you have a small thing, which is pretty cool. Okay, there's one more thing that I want to do actually, and that is to add a VS Code. So because right now, to run this, every time I need to go here and I need to call the Zig build run. But Zig actually, in VS Code you can actually automate the build process, and I'm gonna just grab one from this. I think this is the task that I need. So cool Zig features, let me add a VS Code. And now if I go into VS Code, you're going to see that these tasks, there it is. Basically what it does is that I create a task which says, call Zig build run. And now when I'm here in the build, I can just say Control-Shift-B, and it will start a new instance. And there it is. It has actually ran my code without me using this terminal, right? I can just do this, which is cool. So nice. Let's go into the features that I want to show. Hello, Marcus Don. Hi, I want to learn Zig, but I'm still afraid of the cultural shock. I know C++ and C#. If you know C++, it's not such a big cultural shock. I think that C++ is a much bigger cultural shock. I used C# for like 8 years. I don't know because I was game deving in Unity, and then I started to learn C++, and that was a huge shock. Like it was so hard to figure out things. Some things, because in C++ you can just shoot yourself in the foot so many times. And if I was going from C# to Zig, it would have been much less painful, because Zig is actually a much safer language to work with, and actually much more logical, because C++ has all these weird quirks that are some are inherited from C, but most of them are actually just C++ specific, which is because in every new modern iteration of C++, they're adding new features to solve their old problems, but they just introduce new problems, and you just have to navigate around that and understand how it works. And I think that Zig actually has far less problems of those nature. Okay, so well, let's do a little array here. Let me zoom in so that you can see a little bit easier, and so I can see with my shitty eyesight. Okay, so well, let's make a little array and loop through it. Imagine that we have an array. I'm just gonna call it let's call it array, because we can do that. And the array is going to be the array of i32s. Let's do it like this. And if we put some numbers in, what this happens, I've saved, and well, one thing has happened. Automatically, this line has appeared, and this line appears because Zig doesn't allow adding, not using your variables, right? So to prevent this error from happening, you need to discard the value like this, and Zig format actually does that for you. So it is a little bit weird that it does that. It's like kind of preventing you from doing a thing that the compiler is supposed to help you not have this, it should intentionally tell you that this is a problem, right? Like this, right? We can see unused local variable. But then Zig format just adds this, which is, I don't know. It's a little bit of a weird choice. This is something that I don't fully agree with the Zig in this case. I feel like it should be a warning and not an error, like unused local variable. But anyway, so what is happening here? In my previous streams, I mentioned what is going on here. So this means an array, and this is the type, and this is, of course, the initialization. And what does underscore mean? Underscore means infer a type. Sorry, not infer a type. Infer the number of elements, because when initializing them, right, the number of elements can be inferred. If I said 5, right, it would be correct. It would still be correct. But if I said 4 and I'm adding 5 elements, there is the problem. Expected for array elements found 5. Similarly, if I had 6 elements, right, it would also say it's a problem because it expected 6 array elements and it found 5. So it is a little bit of a weird, so it's not weird. I mean, I actually like this. And this will mean infer the number of array elements. And what if we do this, right? This doesn't work again because it says type does not support array initialization syntax. Inferred array length is specified with an underscore. It's actually, the compiler is actually giving you a really nice error because it says, oh no, you should add an underscore. Why is that? Because this is actually a slice and not an array. So it's kind of weird to see that. It is, in the beginning, it's a bit weird until you realize that this is a fundamental cool feature of Zig, actually. But the syntax is very similar and should not be confused. So if you just have two brackets, open, closed, it's a slice. If you have a underscore or a number, it's an array. And what is a slice? Well, a slice is just a pointer to an array, right? Which can be indexed. So you can say that this is an array. Yeah, let's call it a slice. And a slice is, you do it like this, right? You get a basically a pointer to the array. But in Zig, the pointer to an array is a slice. So if you go over here, it will say, yeah, it is a slice. It is an array. Wait a minute. It's not actually a slice. Interesting. Okay, I am wrong about this. It's not actually a slice. It's actually a pointer to an array. But it can, what it can do is it can, what's the name? Coerce to a slice. So you can do it like this, I think. Let's see if it builds. Yes, it does work. Okay. So yes, it can coerce to a slice if you want it so. So if you define a type, it will turn it to a slice. And what you can do is then, if you do a for loop, so this is what I wanted to show. When you do a for loop, right, what you do is you provide what you want to loop through. And then in the capture brackets, right, in the bars, you provide what do you want your, let me hide the console, what do you want your element to be, right? Let's call it element. You know, maybe it should be E or something, but yeah. So, as you can see, it needs to be used. In my case, I'm just going to log an info, and I'm going to say, hey, element is... And then I'm going to say, oh yeah, I also need brackets because of formatting. Whoops. And then I can say element, right? And now it's going to output me all the elements in the slice. There it is. Element is 1, 2, 3, 4, 5. Okay, so as you can see, you can use a slice or an array. It doesn't really matter in this case because they're exactly the same thing. The slice is just a pointer to the array. If you want to change, now this is an so as you can see, in most other languages, you know, in C++ you would write for element and then do it like this if you want to do a range for, right? But in Zig, you have this capture syntax which comes after. And at first, it is really weird. At first, it feels like, I'm not sure, you know, I really didn't like it at first. When I started doing Zig. But then you realize that these bars are actually a capture, right? Because you're taking the element, you're creating a new variable, which is then captured from this array, from the iterator. It's kind of like this is an iteration and this is the iterand, the thing that you're iterating. That comes from this iteration. And this is cool because it is consistent with how other stuff like, for example, while loops work, because while loops also have a similar syntax where you can capture a variable from for example, an optional or an error. And we're going to go over that later. And you can do the same thing with an if, right? If something something, and then capture a variable. And so as you can see, the syntax is consistent between for, while, and if. Okay, but there is one more thing, right? How do you actually change? So if I try, there's one more thing that comes with capturing. If I try to change the element, if I say element equals, I don't know, 10. So let's change every element, right? Let's try to build. Whoops, cannot assign to a constant. So what this means is that anything that you capture is actually constant, which is really interesting. It's very similar to how functions work in Zig, because function parameters are always constant. And the way that you make them mutable is by providing a pointer. And you can do a pointer by this, right? And now this becomes a pointer to the element of an array. And if we want to change the element, we need to dereference it. And in Zig, you dereference like this, right? And now, what does it say here? Pointer capture of non-pointer type, right? Because array is not a pointer. But if we use a slice, it is actually a pointer. So this was going to work, which is a little bit weird. But if we didn't have a slice, what we can do, if we didn't have the slice, right? Let's remove the slice. What we can do is we can actually do this, right? So this is now a kind of like a mutable for loop, right? Instead of an immutable. So now if I build, you can see that I have changed the value of, well, this is weird. What happened here, huh? The output of the element is i32 at weird address, right? Well, I made a mistake. I actually did not. This is actually a pointer now, right? We can see that this is a pointer. So I'm actually outputting a pointer, and it's an i32. It's a pointer to a type of i32 at this address. So what we actually need to do is we need to dereference this value. So now when we do there it is. Everything is 10 now. And this is another cool thing about Zig arrays, is that you can do multiple iterations of, well, how do we say that? How do I call this? You can loop through multiple. Okay, let me first show you how to do ranges. Could you write star element instead of element? No, because in Zig, the dereferencing is done with this, so it is a little bit different than in C++. And what this is actually cool is that you can then, in C++ you would need to do something like, if you want to like dereference multiple times, you would need to do it like this, right? Or even like this, right? You'd like dereference twice. But here you actually like access and then do it twice like this, right? If it was a double pointer. And it makes more sense like this, right? At least to me. And then when you're accessing an element as well, for example, if you have a pointer to something, right? In C++, you would have something like this, right? And then you would call something like, I don't know, something like that. You're dereferencing a value. In Zig, it's this. So yeah, I actually much prefer this syntax. Anyway, so and yeah, and there's another thing is that when I show optionals later, so optionals the way you unwrap optionals is by doing dot question mark, right? So for example, if you have an optional pointer that I'm going to talk about later, is you can do like this, right? To change the value pointed to by the optional pointer. Okay. Anyway, so well, this is how you do. This is how you loop through the. Let me actually save this. Let's me actually, yeah. Let's put this in a scope. And let's say this. This is an array test. Array for loop test, right? Okay. Array for loop. Let's just do it like this. Okay, and now I'm gonna make another scope. And so, for example, how would you loop through elements? Sorry, how would you index, right? Like in for loop with an index, like in C++, you would have int I equals 0, and then I always forget if it's colon or comma. I think it's actually a semicolon, right? I always forget this because I just use automatic snippet for loops. But yeah, if you have an int I equals 0, and then you would have like I less than some size, and then you would have I++, right? This is how you would write it in C, C++, and C#, basically. So yeah, in Zig, if you want to do something like this, you pre 0.11 you couldn't do this. You would have to do a while loop, right? Because the it was kind of it was a much debated topic in Zig, but Andrew Kelly, the creator of Zig, said that like, well, if you can do it in one way, why do it in multiple ways? So it was like, okay, well, if you want to do a loop through, like, you know, just increment one element, why not just have like a usize I, and then you just do a while I is less than some size, right? And then just increment I. And that was the for loop before. That was the classic for loop before before the new ranges. And yeah, so with the 0.11, it has introduced looping through ranges. So now you can actually do a for from 0 to, let's say, 10, like this, and then you capture an I, and there it is, right? So you capture an I from a for loop from a range. So this means you know, iterate from 0 to 10. And if we do a log info, and we can say something like this, output an I, and let's do a little log info here that says iterate index, something like this. Okay, let's try to build. There it is, 0, 1, 2, 3, 4, 5, right, until 10. Cool. But here is another cool thing, right? Because we don't need to, we can iterate indices like this. But another cool thing is that you can actually iterate through an array, right? You can iterate through an array like this, just with a for loop as we did, right? Array, and we can say element. But here is another new feature in 0.11, is that you can loop through multiple iterators, let's say. So what I can do is I can add a new thing here, and I can say 0 to 10, and then capture an I. So I capture an element from an array, and I capture an I from this range. And then what we do is we can do a log info and just say I, for I, this element is, and then do another one, right? And then we can say here I and element. And so if I build now, what does it say? Non-matching for loop lengths. Oh yeah, one more thing, of course. The length of an array is 5, right? But the array is, so these don't match in length, right? This is going to repeat 10 times. This is going to be repeating 5 times. I actually thought non-matching loop lengths. Yeah, this is actually an error. Interesting. I thought the update, the 2011 update says that it will always loop through the lower count elements. Interesting. So yeah, one more thing that could you do this, that could do, so yeah, I would have to do 5. Let's see if it doesn't cause an error anymore. So if I use a 4, it will not, yeah, it says length 5 here. Interesting. So I thought it actually takes the least, so yeah, what I can do here is I can just do array len, right? And that would fix an error. So it doesn't depend. If I add more, I can do like this. And yeah, it will actually adjust because I'm using a length. Okay, I have to check something, right? Zig, what is it? Changelog 011. Release notes, right? I thought that array, no wait, for multi-object for loops. Yeah, this is how they're called, multi-object. This release cycle introduces multi-object for loops. So you can add, so what this is that another thing that I wanted to mention is that this range is not a special thing, right? What we can do is actually we can have why is multi-object array cool? It's cool because we can have 2 arrays, right? If we have 2 arrays with different values, let's do something a bit random, a bit randomer, right? If we have 2 arrays, what we can do is we can pass the second array as well, and then we can say element 2. Let's just call this E1, right? We have an element 2, and we have an element 1, and we have an element 2. So element is okay, array E, and then we're going to add array E2. No, array 2 elements. Yeah, let's just do it like this. Array, and then we can output 2 arrays. Yeah. So as you can see, I can output 2 different arrays from a single for loop, right? Because it's going to iterate through all of them. And this is the cool thing about loops, array loops. Sorry, multi-object for loops. And another cool thing is that if I want to change, let's say that I want to change elements of this array loop, I can just do I can grab a pointer and do this, and then I can say, okay, E2, I want to make it the same as E1, right? For example, something like this. And so now I'm basically like copying one array into the other. This is a very common thing that you would do between arrays, for example, in some way. Oh, and of course, this is a pointer, so I need to dereference it. There it is. And now they're exactly the same. I've copied 2 arrays. And yeah, this happens a lot when you want to cache something, you want to calculate, maybe I want to have a double, something like this. Well, a double is, I can do more like this. So the array 2 is going to become double of array 1, and there it is. We have all of them, and pretty nice. Yeah, so that's how you can use multi-object arrays. Okay, what happens if I have one less element? Was it going to work? No, they actually have to be all same length. Interesting. Yeah, I wanted to check. Didn't it say that it's going to use the smallest number? Capturing the output element by reference. The index capture is no longer necessary. Arbitrarily many slices can be passed to the... yeah, this is what I was just saying. Note that this is not limited to 2 operands. Yeah, you can add as many as you want. Aha, there it is. The language asserts that all passed slices have the same length. So I completely misremembered this. I have... If they're not, this is safety checked undefined behavior. Yeah. So, as you can see, the compiler actually checks the lengths and it doesn't allow... Well, what if I have more elements in one array, right? Well, what I can do is I can grab a slice of this array, but only as a slice from like 0 to 5, like this. Is this going to work? Tell me this works. Length 5. Aha, this one has length 8. Yeah, well, look what I can do like this, right? I grab an array length. There it is. It works. Cool. So what I did here is that I took a slice. So this actually is a slice of the array 2, which goes from 0 to array length. So it goes from 0 to 8. So it will grab only these, and hence they have the same length. Super nice. Super nice. Cool. So that is all about multi-object arrays, which are pretty cool, and the capturing mechanism. Okay, so there it is. We did that. Next thing I want to show, this is not actually a bug, right? It's not that I forgot to do something. It's not that I forgot to write something, because this, the exclamation mark that you see here is actually error. Errors, which are error types which use an exclamation mark. And these, the question marks, are optionals, because they use the question mark. So how do they work? Okay, let's do a log info optionals. So any type, we know that we have types like var a is i32. Oops, is i32 like this, and then we have a number, right? But any number can also be, you can have an optional type. So an optional type means is or isn't, right? It means that it can be null. And what can be null means, right? It's not like in C#. In C# you also have nullable types, but what happens in C#, it basically a simple type like an int becomes heap allocated. In this case, it basically gets a tag that says it exists or it doesn't exist. So, for example, let's call it a opt. So, or let's just call it a b. And what it does, like the option type is in Rust. Exactly. Yeah, it is an option type in Rust. How you define it is by writing a prepending the name with a question mark. So question mark i32 is either a null, right? It can be a null, or it is a number. So if I just call it 4, it's going to be 4. In this case, let's make it equal to a, so that we can see the difference, and we actually use a as well. And how do we make sure that, yeah, what if I want to put it into something else? I want to put it into a C, right? And C is an I32, and I say, okay, well, I want to set it to B, but I can't because this is not the correct type, right? It says expected type is I32, but found a optional I32. The way you actually make it, make sure that it is, so the way you kind of turn it into a value of C is by using a dot question mark. And now it becomes a C. But this is unsafe. So this is actually going to throw a runtime error if you do this. So if it is this becomes null, as you can see, this works. Let's do a little log info so that we use it. C is C, right? Okay, and what happens in the case that B is actually null? Ta-da! There we go. It says, what does it say? Error. What does it say? Where is it? Attempt to use null value. There it is. Thread this number panics, right? It's a panic, just like in Rust, they call it panics, which means that it's a runtime error. Attempt to use null value. There it is. And yeah, so we get a runtime error by attempting to use a null value. To make it safer, right, what you can do is you can do B. Let's say that we want to make every null a 0, right? What you can do is, instead of just throwing an error and just discarding the error, you can write, there is a, how do you call it? A keyword, not a keyword. Is it the keyword? How do you call this? A word, like null. I forgot, a programming word. The language word, which is called or else. It is a little bit weird. But yeah, I got used to it as well. So you can write or else 0, which what this means is that if B is null, it will actually return a 0. Sounds ominous. Yeah, it does. Or else. I don't know if there is some plan to remove it or something, because like, why not use else? I'm not sure exactly. Maybe it was because else already exists, so maybe it's just something to do with compilation, like, I don't know, because a lot of decisions they made in the language, by the way, about syntax is just for compilation speed. So for example, this thing, which is like a tuple, an empty tuple, is, we don't write it like this, because this is actually a void type. This is not a tuple. And for example, they don't want to make it so that the compiler needs to infer, is this a tuple or a void type, right? Because that's what a C and C++ have this problem, right? Because you need to know the context of where is what used to be able to like compile the whole file, right? So it is like context sensitive, and so Zig is trying to be context insensitive, so that the parser can just go through like this and be like, okay, is there a dot or not? So if there is not, it's a void type. And so I think probably the same thing comes with or else. Hello. So you're rewriting the Shakedown engine in Zig. We'll see. We'll see. I'm not there yet. But yeah, you can use an or else. By the way, I think that Zig doesn't have ternary operators, so you can't do this, right? You can't do this in Zig. But I think you can use an if, actually. Can you? I'm not actually sure. If B, and then you can capture value, and then, yeah, what do you do now? You return value? I'm not sure actually, but I think you can do it like this. Let's see. Okay, Zig, ternary operator. Ternary if there's no ternary operator. Yes, you can do. Oh no, this is Kotlin. This is not Zig. I think you can do an. In this sense, yeah, you can somehow do this else. I'm not exact. Wait, it has compiled or not? No, yeah, return doesn't work like this. What if you do else? Else 0. No? What if you just write it like this? No, it doesn't work. But I think it does have inline if somehow. Well, I don't know how to find it. Zig if expression. If. Does it have an if as a special? Yeah, there it is. If expressions. Ah, there it is. Const result if. There it is. You can actually do it. You can actually do it. Okay, so let's try to do if b is not null, then 1 else 0. Right? Does this work? Yeah, it does work, right? There it is. It works. But what if I capture a value like this? There it is. Okay, so it works. You just need to write value twice, right? Because you return a value from an if, and there is an else. So yeah, this is basically the ternary operator in Zig, right? But so that you don't write this whole thing, what you can do is just, so this is basically equivalent, right? This saying b or else 0. So these two lines are equivalent, right? But for to make it shorter, you can write it like this. And of course, this is even shorter, right? But it throws a panic, so you don't actually handle it. So I'm just going to do it like this. Hello, GCB Mario. Sokoban is a nice game. I want to. Oh, sorry. I want to make a simple Sokoban clone in several languages. I did it already in D and in Rust. Zig is next, hopefully. Sokoban is a nice game. Was my first at university in assembler. Great. Are you intending to also make it in assembler? Cool. So yeah, that's a very good practice to do it. I have this. I also made a little. I did this with a. I call it the. I don't have it here, but I have it on my other PC. I call it the file renumberist, which is basically what it does is it takes files from a folder, right? You run it in a folder, an application that you run it in a folder like here. And then it takes iterates through each of the files and changes the name to 1, 2, 3, 4, 5. And then also goes through entire tree, right? It goes inside and it renames 1, 2, 3, 4. And I needed this for some specific thing. I can't even remember what I was doing. But what is interesting is that I made the same thing first in Python, then in Rust, and then I also tried to do it in Zig, but I didn't finish it in Zig. It turned out that, in Python it was crazy simple, right? It was super simple to do this. In Rust, it took me like a whole day to implement because Rust has all these safeties that you have to, in the same way as Zig, right? You have to unwrap everything. You have to, does the file exist or not? You have to handle every error. So it took a long time to make, but essentially, eventually I did make it. And then in Zig, yeah, it would be interesting to make it in Zig. So that's kind of my Sokoban, right? A file renumberist, as I call it. Just renumber all the files. You could... assembler is too low level for me. You could create a Game Boy version in assembly. Would be interesting. Yeah, maybe you could do assembler in some emulator or something. In a yeah, I don't know if I don't actually know if the assembly code would run on a modern PC, but maybe taking some old PC from the 80s or something. You know, with some very simple instruction set. That would be interesting. Yeah, like a Game Boy. A Game Boy, Commodore, or I don't know, something like that. Okay. So, optionals, there you go. You understand optionals now. And of course, you can return optionals from functions. You know, if you have like, yeah, for example, what could be an optional? I don't know. You could have a function that, I don't know. Let's have some kind of a struct. Give me an example. I don't know. Game Boy is actually a good idea because there exists good tools. I don't remember the emulator, but it basically is a full IDE with memory viewer, debugger, disassemble. That sounds pretty cool. Nice. Maybe there is actually a fantasy console out there, something like Pico 8, which is like more like a bare bones instruction set thing, similar to a Game Boy. I don't know. Yeah, by the way, in Zig, the way you define a struct, you can have... Oh yeah, one thing to do with Zig is to make a linked list, right? You have a node in a linked list, which is going to be a struct. And let's say that the node can contain another node, right? And another node is is an optional. And yeah, I don't know. You could have like a parent. Oh yeah. By the way, I forgot to say that. Yeah. Oh, by the way, let me do this later because this involves optional pointers, which I'm going to talk about a bit later. Okay. Well, you understand the gist about optionals, right? I hope you do. It's pretty simple, right? Use or else. One thing. Oh yeah, one more thing. There's more actually about optionals. One thing is that you can do an if, right? If you do an if, let's say that I want to run some code if my B is an optional, right? It exists, and if it doesn't. What you can do is you can just say if B. And what this will do is B exists. And else I can say, right? I can say log info B is null, and I can cry. There we go. Right. And there is now, if I try to build, it says, oh, expected type bool found optional I32. Yeah, in Zig, optionals do not automatically coerce to a bool. Unlike in C, C++ where you have pointers, or in Unity where you can just like say if something that's nullable. But in C# you also have to say null. So here you have to explicitly say, oh, B is not null, right? And if B is not null, then do this. But there is an alternative syntax which involves capturing a value. Because you can take an if. Let's do actually a copy of this, right? You can say, let's say here log info if with optional capture, like this. And now, oh, why is control? Interesting. Okay, it's actually a shift enter is insert a line and not control. Okay, what you can do is you can actually do an if b and then provide a value here. So what it does is that it's going to capture the value from b if b is not null, right? If b is an optional that has the value. And then we can say here and is this, right? And we can provide the value as value. There it is. So as you can see, there it is. With optional, b is null. Well, in my case, b is null, but let's make it 5 or something, right? And in this case, whoops, I did a Zig build run. I actually wanted to do a Control-Shift-B. There it is. B exists and it's 5, right? In this other case, B is just not null. So that's optionals, which is cool. And you can see that you can capture it like this, or you can use an or else. Or you can just unwrap like this, which is unsafe. Okay, let's go to the next thing. We did errors. Sorry. Oh, I actually was showing optionals and not errors. I made a mistake here. Okay. That is pretty nice. All null values here are the same. I mean, the null from question I32 would be the same than the null from a float. I am not exactly sure. I think that optional pointers are actually... I'm going to talk about it later, but I think the value of optional pointers, if they're null, is actually 0, just like null pointer. When it comes to floats, I think that there is either, there is like a byte reserved for that or something like that. So I'm not entirely sure, but there is some kind of a mechanism which is quite optimized. Maybe the docs actually say how it is implemented. Let's say optionals. Let's search for optional type. Okay. So it provides safety without compromising efficiency or readability. So it says without compromising efficiency. So yeah, it is optimized. Question mark in front of it. I showed that. Or no, the worst mistake of compute. Instead of integers, let's talk about pointers. Okay, I'm gonna talk about pointers a little bit. Okay, let's talk about pointers now. Let's talk about pointers now. Okay, I'm gonna skip errors because this is much related to optionals. From the type system aspect, are they all the same? I don't think they are the. I'm not sure. I don't actually know. Yeah, that would need some googling. Oh, by the way, somebody has asked me before. Are you still working on your Unity project? Well, the only Unity project I'm working on actively is Podvarak, which I haven't touched in a few months because of Shakedown. And because of other stuff. But yeah, I'm thinking now about what am I going to do with it. Because I've already done like 2 years of work into Podvarak, right? And yeah, I'm still thinking about what to do with it. Where to go. Probably going to finish it in Unity. Yeah. Because I've already chosen my path long time ago. We'll see. We'll see also how this Unity thing comes out. Okay, so pointers. Yes, let's talk about pointers. So as you have seen, pointers. Let's put a star because it's a pointer. So basically, how pointers work in Zig is that you can grab a, if you have something that is an i32 42, of course, you can grab a pointer to that value and you can say let's call it a pointer is a pointer to a. So it's very similar to the C syntax where you have a pointer to a something, and what does it say? It says it's not used, but it says that the type is a pointer to i32. And the way that you can change this value is you can point it into it with like this, right? And you say, okay, I changed it. Log info. Let's output a now. A is a. So let's see what the value of it is, and it is 12 because we have changed the pointer. But this is interesting. This is interesting in Zig. Pointers can't be null, unlike in C and C++. So pointers actually behave more like references in C++, right? So if you have a struct or something, if you have a, I don't know, you have a struct that takes a struct with pointer, and you have a pointer that is of type, pointer i32, and something like this, and then you create a pointer, wait, this is going to, oh yeah, of course, this needs to be a struct equals struct. Forgot about that. Okay, and I say, create a new struct of type struct with pointer, and like, what does this mean? And I'm gonna like output a log info struct value, right? What is the value of this pointer? And if I take a str, putter, and the references, right? Well, I tried to build it. You can already see it has an error, right? I tried to build it and it says one error, missing struct field pointer, right? A Zig forces you to define each of the values, right? It doesn't allow you to have a value that is not initialized. Basically, it forces you to initialize everything. You can explicitly uninitialize. So yeah, what you need to do here is I need to say, well, pointer is something. But here is the interesting thing, right? Because it doesn't actually allow me to have a null. And it says expected type pointer i32 found type of null. So yeah, it doesn't allow you to be null because this is a non-nullable pointer. Pointers in Zig are by default non-nullable. And this is where optionals play nicely into it, right? If you want to make it behave like a C pointer, you need to make it an optional pointer, right? So if this is now an optional pointer, this is now a null. So, but now I can't just unwrap it, right? I can't just dereference it because this could be a null reference, which in my case is a null reference, right? What I need to do is I need to first unwrap the optional and then grab a pointer, dereference it, right? Like this, as I mentioned it previously on the stream. But now if I try to run it, it says, whoops, panic attempt to use null value, as we have previously mentioned, right? You attempt to use a null value and it doesn't let you do that. It panics at runtime, which is really, really, really nice, right? Okay, so by the way, you don't have to, if you have really a null pointer, you can just say null here, so it will initialize to null. And now I don't need to actually pass I don't have to explicitly initialize at instantiation point, right? What I can do is just this, and every instance of a struct will by default be null. And then I can make it into, like, if I can say if a pointer is a, right? It is a pointer to A, for example, and there I can now output a value, and it is A. So now we have a struct that points into this pointer. So basically, as you have seen, you have a pointer that is non-nullable by default. So it behaves like C++ references, right? It's non-nullable, and it cannot be 0 because it's non-nullable. But if you have an optional pointer, then it can be 0. And this actually unwraps. If you would read it in C, this actually unwraps as 0. As in C, yeah. So C-like pointers are basically this, optional pointers to something. Okay, but by allowing it to be declared as null, we have the same problem in C or not? Well, it will detect that, well, you have the extra step of having to unwrap it, right? So that is the difference. That's the difference, because you need to explicitly unwrap it. So you can write, of course, you can write everything like this and just dereference it. But there is essentially a null check here, which exists in the safe version of Zig. If you actually compile this with fast option, which will make your build optimized, I think it will probably not have this. But when you're in, it will actually just take the pointer straight. Maybe it does some check, because it knows this at compile time that this is null, because I haven't changed it, right? It's not like something that happens from externally here. So maybe the compiler is smart enough to figure out, oh, this is a null, so you can't even compile. I don't know. Maybe that's too smart for the compiler. But yeah, essentially, while you're debugging, you have a much better message that says, whoops, this is actually a null pointer. So, in C, what I would do is I would just write assert, assert like pointer, right? That's what I would do, like, because then it would throw an error if it's a null pointer. But yeah, here in Zig, you have a much, I think it's a much nicer syntax. Okay, so those are pointers, right? And one more thing about pointers that I didn't mention is that in C, of course, what you can do with pointers is that you can also do, like, index it, right? You can say a pointer and, index it at some point, and it will actually do arithmetic. So if I say, I don't know, a4, something like this, right? But here is what the error says. It says type *i32 does not support indexing. Operand must be an array, slice, tuple, or vector. So pointers in Zig do not support indexing, but to be compatible with C, it does actually have something which is called an indexable pointer. So this is not something that you should use in Zig normally, but if you're interacting with C code, you can actually grab a pointer basically with an unknown value, right? Because you should only index stuff that has known length. But if you have a thing that has an unknown length, what you can do is you can actually cast it into this, which is like, basically, instead of writing this, which is a pointer to a single element, right? In my case, this should work. What you can do is you can wrap this star around with array, right? And what this means is that it will grab a single pointer cannot cast into many pointer. Yeah, this is what I call a many pointer. So a many pointer can be indexed, right? But it's unsafe. So Zig explicitly basically tells you, like, be careful, this is unsafe. You should never use this in actual real Zig code unless you're interacting with C. So yeah, let's try to grab it from A. Let's see if this works. Is it going to work? No, it doesn't. A single pointer cannot cast into a many pointer. Can I actually somehow pretend that this is a... Okay, what if I add C? Oh, this works. There it is. You know why? Because this C, this little C means this is C-like pointer. And let's try to actually... Yeah, because there's another thing. So there's not just many pointers, there's also C-like pointers. Because C-like pointers are indexable, right? So what we can do now is we can take a pointer and I can either dereference it like this. Let's try to do this. Right? Is it going to work? Yeah. But I can also take the first element like this and output it. There it is. It's the same thing, right? Let's do like, okay, these two are the same things. So this is very similar to a putter, either if you dereference like this or if you write it as a index 0, right? So C-like. But yeah, I guess you can't cast into a many type. I guess you can cast arrays, right? I don't actually know. Let's try this. Let's see if I can do an I32 1 2 3 4 5. Say we have, okay, well, we have 5 elements, and then I can array pointer is going to be a many pointer without... Does this work? Yeah, it does work. So this is like a many pointer that only has... So, oh yeah, the extra step is good and the error is better. Yes. Talking about the optionals here. So yeah, what the many pointer can only be cast from an array, from a thing that has multiple elements. Yeah, that makes sense. That makes sense. So the C-like pointer can be gotten from anything, basically, right? So yeah, let's say our pointer C. Let's try to do it with the... Can I actually cast a pointer into like this? Is it going to work? Log info C-like. And I'm gonna grab an array pointer C dereference, and let's do a many pointer, or no, yeah, let's do it like this. So what happens when I do a many pointer? Aha, yes, I can't. Unknown length pointer type cannot. So yeah, I cannot just do this, but I can grab a first index probably, right? Yes. Yeah, there it is. Why is this? Oh no, it's because it was selected. Yeah, so many pointer 1, C-like 1. So you can see that the C-like pointer, the difference is that the C-like pointer can be both indexed and dereferenced like this. And the many pointer cannot be dereferenced like this. It can only be indexed. So that's a bit of a, you know, it is weird at the first, but then you're like, oh, okay, it makes sense. And it's nice that it actually exists so that you can interface with C code much nicer. So yeah, cool. There you go. You have all kinds of pointers, including optional pointers, which you should use if you have a thing. So yeah, the way you can make like a hierarchy is basically by creating a struct that is a, you know, that has a node and contains the node itself, but of course it cannot contain a node because that would mean it's a infinite recursive, you know, it will never be instantiated. Let's actually see what happens here. Is it possible? Is it going to compile? Hello, привет. I don't know what you're saying. I'm not Python лучше всех. So I don't speak Russian. Anyway, yeah, this actually compiles, but is it actually going to be able to be installed? Let's see what happens, because this should be impossible, right? Because a node contains another node, and then the subnode contains another node. So yeah, this should be impossible to exist. Let me actually add it into a separate scope here. Oh, there it is. It says use of undeclared. Oh, it does. It only says use of undeclared. Okay, no. Let's do here. Log info. Impossible node. Okay, what happens here? So if I create a node, yeah, I started writing in C style with the first, but no, you should actually do an var. And then I'm gonna make it a type node. No, wait, I'm gonna instantiate it like this. And let's see what a compiler says. It says, oh, it just says use of undeclared. But is the compiler going to actually give me something that makes sense? Use of undeclared, following command cannot compilation errors. Okay, it just says use of undeclared identifier. Okay, what if I make it undefined for now? No, wait. What if I make it... What if I make it just node itself? Is this actually going to work? Use of undeclared. You see there's two of them, so maybe it is trying to recurse. Use of undeclared. Okay, it is still undeclared. Undefined. Okay, what if I undefine? Use of undeclared. It's not very clear that this is a... it's undefined because it cannot use itself. I guess. Or maybe use of undeclared identifier. Maybe because it's not declared correctly, right? But what if I take a pointer to the node? Optional pointer to the node. What happens then? Oh, it doesn't exist then as well. Interesting. So it doesn't have it doesn't know about the node because it's inside. So how does it actually work if I want to take a self? New rally game, maybe. Hello, man. Hello, Alele, by the way. New rally game, I'll see. Okay, so how do I... yeah, there is actually an example of linked list in Zig, which is super simple. Linked list. Okay, let's see, what does it do? Self. Okay, maybe I can do it with a self. If I pass a self like this, then I can grab, then I can have a self. Make it, there it is. Okay, so this works because this means that it takes, basically it's a compile time thing which says, okay, I want the type of what is the self. The self type, right? That's basically what this does. This returns the innermost struct, right? And this is the innermost struct. Okay, so what if I have it like this? Is it going to work? Aha! There it is. There we got it. It seemed to work in global scope and not in function scope. Yeah, I guess maybe it worked in global scope. But there it is. We found it. And it actually caught this error, which is great. Depends on itself, right? Node depends on itself. So you cannot have a self contained in the same thing. Because then this node contains the node itself. And so it's like an infinite loop of nodes, which is impossible to instantiate. And it says here is while checking this node, while checking this field. Ah, okay. So it's like depends on itself while checking this field or something like that. Yeah, I guess that's the problem. Cool. So yeah, but what we can do is actually, if I want to have, let's say, yeah, we have like a sub node. We could have like let's say it's like kind of like a hierarchy, and we can have a parent, and you know, we can have a parent and a child, and a parent and a child could be an optional pointer, right? Because we're pointing into some objects, right? It's a so yeah, that is where that's an example where you would use optional pointers. So yeah, now we can have like one node. We could have, oh yeah, and this actually needs to be the problem. This problem, it says missing struct field parent, missing struct field child. So we have to explicitly define here, but to avoid explicitly defining, I can just say it's null, right? Like this. And now it's not going to complain because by default it's null. But we can actually override it. So we can say, okay, let's say between a node. Okay, let's call it like this. Top node, between node, and I'm gonna make a lower node. Something like this, right? And between node, the parent is top node, because we know that. In the lower node, the parent is lower node, right? But we also have two more relationships, because the top node's child should be between node, and between node's child should be lower node. But of course, we have to take a pointer, because yeah, it's not a it is an optional pointer, right? Like this. So we have connected, like, you know, the hierarchy of things. What is going on here? Use of undeclared identifier lower nodes. Oh, right. Because I'm doing it self. No, it's not self. It is between nodes. There it is. So we have connected them all now. And now we can, like, sort of recursively go through children or something like that. Right? I can take a var child. I can say, like, next child or something like that equals top node child, and then yeah, let's actually take top node as a beginning, right? I could take a pointer, and well, in this case this is going to be a pointer to the node, but let's see if so let's do a while next child. Aha. So we do actually have to make it nullable. So I'm gonna make a nullable pointer, and then I say while next child is not null, right? But what we can also do is we can capture it with this. Yeah, well, let's do this later. Const next child. Yeah, let's do it like. Let's do like a pointer so that I can take next child like this. I take an optional, and I'm gonna output something. I don't know. What can I actually output? Let's say that this has some kind of a text inside. I don't know. Let's do a const8. And let's call it default. But for each of these texts, I'm going to add something. So I'm going to say, in this case, the text is top, like this. In this case, text is middle, with the frown. And for the last one, it's lowest, lower, right? So that we can output them. So that we can output the names somehow. Okay, and now I can say node is next child is, and then of course I need to output a string with an S. I can say next child pointer dereferenced text, right? Next child is string. Okay, so basically, and now I output it and I say next child should be the next child's child. But I also already have a pointer, right? Next child pointer, right? And this is interesting because, you know, in C, C++, you have to use this to dereference. Actually in Zig, you don't have to do it. Right? If I have, oh yeah, because this is not a pointer. No, wait, it is a pointer. So how does this work? Don't I need to dereference it first, like this? Okay, let's actually try. Maybe I made a mistake. No, it actually works. So I can dereference, and I don't need to dereference. Yeah. Actually, this is kind of weird. So I can choose to dereference or not to dereference. I find this kind of awkward. Interesting. That's a little bit of ambiguosity from the side of a Zig, which is Zig is trying to not be ambiguous. That's kind of in its zen. But this is a little bit ambiguous. Like you can grab a pointer and like this. So maybe because it is a pointer, it is a sub-pointer of a pointer. I don't know. Maybe that's why it's a special case. It is interesting though. But yeah, there you can see that it works, right? We're looping through all the children by going down, which is very good, right? We have these optional parents and children, and we have connected them. And now for each child, we're just going through the hierarchy. Great. That could be a use case in real code, right? Next child, yeah, but I also wanted to show you that a while loop has also a really cool syntax, which allows you to capture. Actually, I already showed you that with when I was showing optionals, right? Like here, if. But it also works in a while loop. So what you can do is instead of having all these pointers here, I can actually move this into a capture. So I do a while this, and then I capture the next child pointer like this. And there we go. So what it does is that it will do a while it exists, right? When it becomes null, in this case, right, when I reach the end, the child is null. When it becomes null, it actually the while loop actually ends. And yeah, let's try this. There it is, top, middle, lower. And another cool thing is that the while loop actually has an else. And what else does is that it runs after while loop finishes, right? So we can say reached end of tree, like this, right? And now when we output reached end of tree. Why is this important, right? You might think, well, we could have just put it out here. But what it actually does is that you can, what if something breaks a while loop, right? If it breaks, it will actually run. This is actually going to run. But sometimes you actually do want to run else only in the case that while is null and it has reached the end of loop. So if I break here, the else is never going to run. There it is. Next child is top because only once it looped, and this has never run because it's in the else block, and break has broken the while. And it's nice. It's nice that this exists in Zig. Okay, let's go on forward and let's talk a little bit about pointers. Sorry, We talked about pointers. Let's talk about errors. So errors, a little bit similar to optionals, in that error types actually, yeah, let's do a log info errors. Errors like this. Okay. So error types, we have a normal I32, right, like this, and it is some number, right, 42 of course. But if we preface A with error, if we preface the type of I32 with a bang, as some people call it, or exclamation mark, it becomes an error. And what this means is actually it's expected type expression found. Yeah, it does expect an error type actually. But this is what I'm what I'm trying to say is that this actually means it's a number or an error, right? But here is the catch. Error needs to be an enum. And this is why this is a problem, because it expects an error type. So what is an error type? Well, it is a simple enum that we can define as an error, and I can call it an error. No, wait, I can call it whatever I want. I can say my error, and then instead of normally for enums you would say enum and then define you know, some enum types. In this case, it's going to be an error. So what it becomes an enum, but a special error enum, and we can say some error. I don't know. You can say number error, which you can call it like this. Okay. And what happens here is that the number error that we have is a special kind of enum that actually all errors in the whole applications, the way they work is that all errors in the whole application are actually combined into a single enum, into a single number, right? And this is how it kind of like optimizes errors, and how errors are actually work fast. And so this now we can add into our error info. So we can add it here. And now this is either an I32 or my error. And if we want to make kind of any error that we want, we can type in here any error. So this means that it's combined all errors, all possible errors. But in the case that we want a specific one, we can do a specific one. And yeah, and this means that we can return, which means that we are limited to all the possible errors that we have defined, right? So it doesn't really make sense in this case, right? Because like, why would we define a value with an error? This is kind of weird. It is slightly weird. But yeah, in this case, by the way, we can either assign it a number, or we can assign it my error enum. Oh my god, what am I doing? My error, right? Which is a number error, for example, like this, right? And this only exists because it needs to be, yeah. Oh, one more thing is that if I want to unwrap this error, right? If I want to assign it into a different value, let's say B, what I need to do is I need to use a try keyword and try A with error, right? And what happens here is that it will assign B if this is not an error. And what try does, it throws an error at runtime, right? It will panic. And so it is very similar. It is very similar to optionals. But in the case of optionals, we used an or else, or we used a unwrap like this, right? So if you can see here when I was explaining optionals, where optionals. This is optionals. There it is. I showed that you can either use an or else, or you can use an if with a captured value, or you can unwrap like this, right? With just like this will panic at runtime. If you want to make, if you want to capture the error, what you can do is you can use a catch keyword. So if I want to make another value that takes this value and is not, oh yeah, by the way, let's try to run it. So because I made it in error, oh, I made the same spelling mistake as there, right? Okay, let's do it like this, right? If we get this, it will say error, the following, what does it say? There it is, error, number error. So this is cool. It like tells you, hey, this is a number error, and yeah, this is a number error. And we could have any kind of other error here, right? Yeah, try a with error will like, you know, try basically throw an error because we tried, there it is, we tried to unwrap the number expecting the number, but nope, it was an error. And it doesn't really make any sense here, but let's make actually a function where it makes sense. And one function that is very typical for, you know, where an error could happen, of course, is divide, right? Let's try dividing a number. And let's have, you know, A and B, and A is going to be, yeah, let's just do an F32 in this case. Let's just try to divide A by B, and of course, what I'm going to do here is I'm going to return an error, an F32 with an error, because, of course, if B equals 0, I want to actually return an error, right? And otherwise, I'm going to return A divided by B, right? So this is how we can catch an error in case of a division in this our example. And for the error, I'm going to grab, I'm going to make a new enum, right? Which is going to be, let's call it division error. And we're going to make it an error and have a division by 0, right? There we go. This is our error. And now what we can do is we can return division by 0, right? Expected state found else. What is the problem here? Maybe, okay. Does it actually work with, okay, ifs don't need to have brackets, right? But when there's an else, it does need to have a bracket. I think that's the problem. Yeah, that's probably the problem. Okay. So in this case, we return a division, right? We return a correct number, and if it doesn't work, if it's a 0, if the what's the name of it? Divisor? I'm not sure exactly. The second number, if it's 0, it doesn't work because we can't divide by 0. And it's going to return me an error. So now, if I try to use an error, if I try to use a number, let's just make this 42 so that it doesn't throw an error. We can say division is divide, right? Divides, I don't know, let's do 21 by 3, and yeah, and what it does is that log info, let's say division result, and if I try to divide this, what happens is that it throws an error because it's compile error unused argument. That's our first problem in an FMT. And then second problem is that it says cannot format error union without a specifier. So yeah, this result is actually a error union, right? As we can see here. And to unwrap the error union, we can use a try keyword. Alternatively, right, this is going to work now, right? There it is 7, right? Division of 21 by 3, it's 7. But here is the problem, right? The problem is that division is not, okay, this is, yeah, I wanted to actually show that you can actually, if you take the error union, you can actually put bang inside and it will automatically unwrap. There it is. So you can form it like this. Okay, so what happens if I put a 0 inside here, right? Well, there it is. We get a result as an error, as a formatted, right? So in this case, because we have formatted as error or the result, it will tell me that the error is, that the value is error division by 0. Well, you can instead, you know, if this value is F32, then it's going to, boom, there it is. And it says error division by 0, right? So there we go. So this is how you do it, right? You return an error union, which means that you have a number that contains an error inside it. Cool, right? And you know, you could have more errors, like, I don't know, operand is nan or something like that, right? So if you have, if we have, does a nan exist? I think so, right? You can do like, okay, let's do something like this. Let's do an else, else if something, else if A is not, what is impossible? I never saw impossible. Okay. How do I have nan is nan? Okay, does nan exist as a built-in? It doesn't. So I think it's probably math is nan, right? Is nan any type? Yeah, there it is. Is nan or std math. Oh, std math is nan b, for example, right? And then we're going to return division error operand is nan, for example, right? So we catch another error, which is going to be part of this error. And so in this case, if I force this to be nan, like this, I can say nan F32, right? And I try to divide a nan number with 0, it's going to tell me, whoops, there is a problem. There is a problem. Deprecated. Use nan F32 instead. Aha, okay, so this is deprecated. I'm going to use an F32 like this. Interesting. Okay. I've never used the nan before. Yeah, this is cool about, oh my god, this is so cool about Zig, because I didn't even know where nan is or how nan is typed. But I just assumed that it must be somewhere in the standard library, and I'm just like, oh, math is nan there? Yes, it is there, right? And you know, if it was C++, I would have to like Google, like, how do I do nan? It would be some kind of a weird macro, or somewhere down in the depths of like std limits or something. So yeah, that's cool about Zig. Everything is in there. Everything is in std dot, and you get all the things. Okay, so let's try this. Right? Oh, I didn't want a new thing. I want it to be, there it is. It says, wait, error is division by 0. So it caught a division by 0 sooner than my nan. Okay, let's try to do a nan. There it is. It says, whoops, errors operand is nan. There we go. Beautiful, beautiful error, right? Okay, so what if what if I'm going to actually try to see how it looks like when you run it like this. What is going on? Info pointers. It is blocked. Oh, it is blocked because I'm... Okay, let's run this in a terminal. Undo copy. Whoops, redo copy. I don't know what I did. Okay, open in terminal. Let's do a cool zig exe. There it is. Aha, so it just says operand is nan, and it will actually tell me this. But yeah, running from VS Code, it's a bit nicer. So it does, yeah, it does say operand. This is just because we're running in debug. I wonder how it is when it's running in release. I'm going to test that later, right? I should. Okay. So that's errors. Errors are pretty cool. You can return errors. They're different from optionals because instead of using a null, they actually return an error, which is just like, yeah, and you can actually, if you put a comma, it will actually list them like this, which is nicer. If you don't put a comma at the end, it will, you know, it will format like this, which is cool. Okay. So yeah, you can just stack these errors and you can pass those errors around. And of course, by the way, in this case, I'm assuming that this is like an any error, right? And I can actually return whatever error I want. If I had a different error like this, I can say another error, is error. And you know, I could move this operand is nan into here, and then I could pass this another error in here, right? So, oh, this should be a. So yeah, we have two different errors returning through a single type, and if we run it, it's going to have the same thing operand is nan, right? And how does this work? Well, this works because these two errors are actually combined together into a single enum. As I said, all errors in the entire application are actually combined and are like kind of like in a single array, right? Which you get this text in info, which is pretty cool actually. So yeah, but you can of course specify a certain error. You can say, okay, I want only to output division error, and this actually makes it a little bit easier for whoever is using this function, because you can now have introspection into this. You can say divide. Okay, I'm actually returning an F32 or a division error, so I know exactly what kind of error it is. And of course, this should not allow me to use another error. Let's see. Ah, there it is. Yes, it does not allow me to use another error because the expected type is yeah, it needs to be this type. Although the message is weird. Expected type error, division by 0, found type error, operand is nan. Maybe just because there's only one. That's why. But yeah, in this case, yeah, I don't want to have two different errors. I'm just going to do it like this, and I'm going to specify that this is a division error. There it is. Okay. There we go. It now compiles, but operand is nan because we have a nan here. Let's not do a nan. Let's do, yeah, like this. You could actually add, you know, if you had, for a formatting, I can also do d :.2. It's a little bit cryptic, but this means it's a decimal point, and the zeros after decimal point are 2. So this is to output floats. You know, if I do it now, it says 1.00, which is nicer than, you know, +0 exponent. Okay, so that's about errors. Pretty nice, isn't it? Nice Zig feature. Okay, let's continue. What's the time? The time is, by the way, OBS now has has chat integrated, which is cool. But I can't. I'm looking at it on my phone anyway. I wanted to see how long I'm live. Oh, 2 hours exactly. 2 hours and 20 seconds. Nice. Okay, let's go on to the next cool feature. Right, I showed Eris allocators. So all the stuff that we've done so far has been on the stack. Everything, because there's basically two types of memory that you can use at runtime. That is a stack, which everything that we define here, like a variable a with error, that's all allocated in the stack. And each function that you call, that's also allocated in the stack. And then after the function finishes, the stack goes back. Simple memory, simple and efficient. But then we also have the heap. So when we don't know the count of things that we're going to allocate, we need to use the heap. And of course, also when we want to allocate a huge number of things. So in this case, for example, all this time we have been allocating fixed size arrays like this. Array, it has 5 elements and that's it, right? And yeah, so in C, you might know that, well, first in C++, in C++, you kind of have, right, you would write something like this. You would have an int pointer and have a little, you would, if you want to create something on a heap, you would say I don't know, a pointer is new, and then you would say number, right? Is it how it works? I'm not sure. No, you would write it like this, right? I'm not actually sure. How would you do it with an int if you want to allocate a single one on the heap? But yeah. Anyway, so here's the thing. This new is a very magical thing. And what new does is it actually, under the hood, it does a C thing, which is malloc. So in C, you get a void pointer, right? Because it's just a pure pointer. And you have some kind of a pointer and you malloc and you provide it a size in bytes. And do you provide something else? No, I think it's only size in bytes. You know what? I have a C test here, which I did today as well. So I might actually just try C code in here. There it is. Okay, I did something. Hello world, the number is... I did a little bit of just trying out C. But yeah, let's try to do some mallocing. Print hop. Okay, I was trying to create some structs. Okay, so yeah, if you want to malloc, it doesn't even exist. Do I have to include it from somewhere? Malloc H. Is that it? Or is it memory or something? Malloc. Okay, there it is. It's only the size. So yeah, what you do is you provide a byte size, right? So you might say if you want to allocate a single int pointer on a heap, you would say okay, let's call it an integer, and then malloc 4, but also I need to cast it into an int pointer because it mallocs 4 bytes, something like this, right? That should work, hopefully. And then what you can do is you can take it and, oh yeah, how do you actually, how do I assign a value? Wait, I'm confused. How do I assign value to the pointer? I just do it like this? No, I need to say equal. Now I forgot. Oh my god. Okay, I don't want to change the pointer. I want to change the value that I point to. So it is actually, it should be a dereference, right? Like this. I dereference, and then I say it's gonna be 12 or something like that. And then I can printf a, you know, I can take a integer and I say, okay, what's the integer? Is that going to be correct? Let's see. What does it say? Starting build. Oh yeah, clexe is not. It's not running. It's unknown because I'm not running it from the command. Oh fuck! How does this work? I totally forgot. I need to start it from the developer command prompt. There it is. And now I have to do code dot, but no, I don't actually want no, I actually just want to start code from the developer console, and then I have to open ctest. There it is. Okay, let's try to build it now. Starting build, build finished successfully, but I don't run it. Okay, so I have to run it as well. How do I actually run it? Where is my tasks? Do I do another thing? Command. How do I run another command after this? I'm not sure. Maybe there is a way to run it. Okay, I'm just gonna do it like this. I'm just gonna say bin, and then yeah, main exe. There it is. Okay, so printf, has it worked? No. Okay, where's my integer? Did I actually compile into a main exit? I think so. My integer on the heap is, okay. Let's see. It's not happening. Okay, is this a different thing? Am I? Okay. Maybe it has it segfaulted and not reported it, or something. Does this work? Okay, I have to build first. Starting build main C, right? It does work. It's kind of weird. Does this work? Ah, there it is. It's just I forgot to actually put a new line. That's the problem. Okay, so let's put new lines everywhere. When I'm printing this hop thing, I did not put a new line. Great, perfect. Okay. Yes, like this. There it is, 12. Yes, so that works. As you can see, I grab a pointer to a thing on a heap, and of course I need to take care that the size of an int is 4, right? Or I can use a size of int, right? That is a little bit of a weirdness when it comes to that, like, and then in C you have to do this like that. But yeah, when you actually allocate memory on the heap, this is gibberish, right? This is gibberish until I assign something to it. So if I didn't have this, if I just say nothing and I run it, it's like, oh yeah, integer on the heap is 163.18656. So yeah, it's like you need to make sure that you make this a 0 or something before you use it. You can also, I think that there is another malloc where you can set there's an align malloc as well. I think that there's some other malloc in a more modern C that will actually assign the value which you want. I'm not exactly sure. Okay, so yeah, what happens here is that what this does, it allocates memory on the heap, and now you can use it, and you can do whatever size you want, right? You can allocate 4 gigabytes if you want, and yeah, your application is going to use that. And one more thing, of course, that we forgot to do this, is that our memory is now leaked, which is perfect, right? Because after you use your thing, you need to free the memory, right? And we need to free it like this. And let's just actually rename this. Does renaming work? Whoa, what did I do? I did 2 times RR and did not try to rename it. Okay, does this work? Rename symbol F2. Okay, int pointer. Oh, it does actually have a integer int pointer. Let's do it this as well. Cool. So these tools actually have renaming as well. Nice. Okay, so yeah, we need to make sure that our pointer is freed, that the memory that we have taken is freed every time. So that is a little bit, it's like on the programmer to know when it frees. That's one of the problems, and as you can see here, it worked. And you have to make sure that it happens after everything, right? And one of the problems is like, what if there is an error? What if something happens here? What if I quit a application here? Well, what happens is that we have a memory leak, right? Because this is never executed. So yeah, this is where some of the cool features in Zig come in, like defer or defer, which I'm gonna talk a bit later at the end. So this is how you allocate things in C. The way you allocate things in C++, well, this is not C++, but the way you allocate things in C++ is that you would call a new, and a new, yeah, I'm not actually sure how to allocate a single thing, because I think, does it work like this? If I had a struct, I would be able to do it like this. But I'm not sure if this actually works. If this would actually work like this, right? Create a new, and then it actually, yeah, it should actually it should actually initialize it. So maybe this would work, but I'm not exactly sure. I don't have a C++ here, so I'm not sure this would work. But yeah, essentially, if you would have a class, you would initialize it in this way. And then you get a pointer, and then at the end, you have to delete it. And so here is the question with all these things. The question is, what is happening here, right? What is a malloc? What is a new? What kind of strategy does it use to allocate these things? Well, new actually under the hood just uses malloc. And what malloc is that it basically asks the operating system to get memory, right? You say, well, I need this size, so please, operating system, give me some memory. Give me this. Give me a space in the heap in the RAM, but it doesn't really need to be RAM. Maybe it's not RAM. Maybe it's virtual space. Maybe it's on the hard drive. You don't know. Maybe you have filled up your RAM completely, and it will give you a pointer, right? And this can actually be really slow, especially if you're allocating a lot. And because you depend on the operating system to give you this memory. And that is why Zig introduces the notion of allocators. So what allocators are, they're kind of these objects that provide you with the strategy that you allocate things, so that you create new memory. And it has a bunch of allocators. You can, in C++, C++ also has a notion of allocators. So that when you're using, for example, when you're using std vector, you can provide, instead of an int, you can provide an allocator as well, which in case of C++, yeah, but the thing is that if you don't provide an allocator, it actually gives you some default general purpose allocator. And Zig actually wants you to explicitly provide allocators for each time you use something that will allocate memory on a heap. So it tries to have no hidden memory allocators ever. Like, you can't just do new int and you're like, what the hell is new, right? What does it mean? What kind of strategy is it? It's completely hidden in this new operator, which, by the way, in C++ you can override. You can override a new operator, and you have no idea if somebody else has overridden your operator. Maybe somebody else is using it, and yeah, so some library that you include. Who knows? Maybe it does. And so Zig, for that reason, forces you to pass an allocator, and in allocator there is actually a bunch. In Zig there is a bunch of allocators. The most, yeah, for example, all of the allocators, yeah, so, okay, let's, yeah, for example, one of the allocators is page allocator. So page allocator is very similar to malloc. It is a system allocator, and you can create it. It resides in std_mem page, no, wait, it resides in heap. std heap, and you can see all these allocators in the heap. There is an arena allocator, fixed buffer allocator, heap allocator, memory pool, but here is a page allocator. So let's try to use a page allocator. I can't remember how this is actually used, like this or this. I keep forgetting. Page allocator. What is it? What kind of type is it? Page allocator const if is wasm. Aha, it returns you an allocator at compile time, I guess. Else if for different allocator. Okay, but I think it does actually return you an allocator. So let's try to put it in a, okay, like this. Alloc init. Can I use it? No, I cannot. So I keep forgetting. Ah, okay. There it is. You can allocate now with this. So yeah, you can allocate a type. So this is basically like saying malloc. And you can say, okay, I want an integer, i32. Wait, it is a type as well, right? You provide a type. And the size is like how many of them you want. So, and what does it actually return? It returns an array of types. I see. Is there like an alloc single or something? Alloc sentinel, and with options. Raw alloc. Yeah, you can just return a void pointer basically. But yeah, in our case, let's do yeah, I can actually grab this, the first element like this, right? So I say var int pointer, just like we had in in C. So let's see. It returns an error as well, right? So it could fail. So I'm just going to add try before it, and there we go. We have an int pointer, and oh, it doesn't allow me to do this. Out of memory. It does not support indexing. i32. Okay, why doesn't it exist? Because it's an yeah, of course, because this is an error type. So if I wrap it like this, is this going to work? It does work. Okay, interesting. So there you go. And in this case, this should now be a... It's not a pointer, actually. It's just a value. Allocates an array n items of type t and sets all the items to undefined. Depending on the allocator implementation, may be required to call free once the error memory is no longer needed to avoid a resource leak. If the allocator implementation is unknown, then correct code will call free when done. For allocating a symbol item, see create. Oh, there it is. It's a single item is with create. Create. Ah, there it is. So I can create a single item like this. So yeah, let's try it with int pointer. There it is. And it does return. There it is. This one does return an pointer. Yeah, I was confused. I was like, wait, does it return a pointer? Yeah, it does, but it's a slice. That's the thing. In this case, this does return a pointer to a single element. And now we can say int pointer is, I don't know, 10. No, let's do a 42, of course. And now I can log a int pointer is, oh sorry, int my heap allocated int is int pointer. This is it. What does it say? What does it say? Oh yeah, of course this needs to be a try because this is an error, right? By default. So there we go. Whoops. Okay, let's try to build. There it is. My heap allocated int is 42. So there we go. We have allocated, we have malloced basically, but it's type safe because we don't have any voids. We're not providing a size, we're providing a type. So this is very type safe. And it also happens at comp time. So it's checked at compile time whether this this can fit, which is great. Which is great. But where are actually allocators much more useful? Well, where they're much more useful when you have a vector, or not a vector in the sense of like a mathematical vector, but I mean like a list that can expand, an array that can expand. And in Zig, what am I actually talking about here? What is there? Allocators. Yeah, what am I left to do? Constructor destructors, operator overloads, and vectors. Yeah, but these vectors are mathematical vectors. Mathematical, not the other kind of vectors. Okay, so yeah. Let me go back from C into my alloc here. Right. Well, one cool thing is that yeah, let's add here heap allocators like this. Okay, and now I'm gonna introduce you to Zig's list, or Zig's expandable memory, and that is called a std array list. That is how it calls an array, right? It calls an expandable array, basically, which is in C++, it's going to be a vector, right? Vector of int, like this, is the same as std array list of i32. But here is the thing. Oh, what happened? Did I accidentally press something? I think so. No, any more chat messages? No. Okay, I didn't fuck up anything. Cool. Okay, so in Zig you have an array list, and the thing is that because it is expandable, what it expects, right, is that you should provide it right? If I say this is an array list, but array list, this is just a type, right? So an array list of i32 is just a type. It's not an actual list. What it needs to be initted, but here it is. You see, it takes an allocator. Because it is dynamic, right? It's going to reallocate and it's going to expand. We need to provide it an allocator. This is the difference between like C++, right? Where allocator is magical. It's just using some general purpose allocator. In Zig, you have to explicitly provide an allocator. And let's just for now use our good old page allocator. And you know what? We can actually, I think you can actually use a const because it doesn't actually do anything. Is it? I'm not actually sure. So yeah, you can use an allocator, and I'm gonna provide it a page allocator like this. There you go. And now we have a list. And it says unused because we're not. Okay, and let's append some values, right? In C++, this would be called a pushback or an in-place back, depending on whether you use a constructor or not. In C#, this would be called add. In Zig, it's append, right? You append a new item at the end. And yeah, let's add some numbers. I don't know. Let's add a 4. Let's add what number do you like? My favorite number is actually 31. There you go. You have my favorite number. And because it's like the opposite of 13. So, 31. Yeah, and there you go. We can append things. And here is the thing. We have no idea if this array is going to run out of memory, right? So look at this. It says, we have a problem. Error is ignored. It's ignored because we have no idea if this is going to fail or not. And in this case, we have to put a try in front of every appendage that we do, right? And at the end, let's output them. Let's just output them. And I'm going to output them by just providing a list and saying, you know, oh, yeah, this is my, yeah, let's just call it value, actually. Let's just call it value. And I'm going to log info the list value like this. And let's do a value, right? Okay, let's see if this works. Ta-da! Bam! Array list is not indexable and not a range. So here is the thing about Zig. Zig doesn't allow you to overload index. Like, you can't actually index a non-built-in type, right? You cannot, like, unlike in C++ where you can overload anything. You can overload operators, you can overload functions. Zig doesn't have that. You can't overload operators, you can't overload functions, okay? That's how Zig works. But what it does is that you can index, of course, through a backing array of the list. And this is called items. And so this is actually the slice to the data of your array, right? And so that is actually iterable, right? In Zig, things that are iterable are arrays, slices, and those multi-item pointers, right? Those are many item pointers, right? I think so. I think they are iterable. I'm not sure. But yeah, basically Zig says those things are iterable and you can't iterate otherwise on anything else. Okay, maybe you can iterate on enums. I don't know. But yeah, I don't think so. Maybe you can grab a slice or something. Or just oh yeah, you can also iterate on ranges. I totally forgot about that. Yeah, because this said it's not a slice array or a range, right? When I had this error, it said, yeah, there it is. Well, there you go. There's my there is my answer. For loop operand must be a range, array, slice, tuple, or vector. There it is. So that's a really cool thing about Zig, is that you can't magically overload. You can't create magical iterators. It just says, no, these are things that you can iterate through: range, an array, a slice, a tuple, or a vector, and that's it. No more additional things. So yeah, instead of list, I'm going to iterate through list items, and let's see if that builds. There it is. List value 4, list value 9, list value 31. There it is. We have appended a few things. Another thing that, list has a lot of cool things. We can remove items. We can, you can also swap remove, which is very useful if you want to do optimized removals, right? You can take a thing, you can take a value. If I take 0, what it's going to do is going to replace the last member with the first, right? And then decrement the number, the size of the backing array. So it is a super efficient way to remove items without changing the order, which is super important for games, for example. So if I swap remove 0, it does actually return me a T, which I can completely discard. And as you can see, there it is. The first value is now 31 because it has replaced the first value. If I don't actually explicitly discard, it's going to tell me, whoops, you cannot, value of type i32 is ignored. This is what I'm talking about when I'm saying that Zig is nice. Yeah, you have to explicitly discard things when you're not using them. There it is. So now everything works. We can swap remove, but we don't need to swap remove. We can also remove normally, right? And you have so many things that you can use. Add many as array, add one, append, allocate a slice, append the slice, assume capacity. What is that? Append the slice of items to the list, asserting the capacity is already enough to store the new item. Does not invalidate pointers. Aha, this is really cool because, my God, this is amazing. This is what I wanted in C++ collections. All these things, right? What it does actually is it checks if there is enough capacity. So it's kind of similar to saying just like if capacity can fit, if it can fit, add items. Great, very useful. Yeah, and you can see all this stuff by just saying dot, and then look, you can get all the stuff. Get last even has that. Yeah, C# vectors don't have that, but C++ vectors have. I say C# vectors. It's not vectors. It's lists. C++ has back. You can say dot back. Yeah, and in int capacity, you can also initialize with capacity, right? So in this initial, when you init, it actually has 0 capacity, right? And then when you add stuff, it will reallocate. In this case, like if you init with capacity, it will initialize and malloc immediately. Pop, you can remove the last element. Pop or null, right? Pop or null is pretty cool. Like, if it's an empty thing, then it will just return a null. Replace range. Yeah, so many things you can use. Shrink and free, swap remove, as I saw. But how do you actually remove something in the middle? I want to try that. Clear and free. Nice. So clear and free. Oh my God, I remember that somebody on Twitter had this question. Like, does clearing actually, will it actually like remove the memory or not? Like or was it like shrink? Does shrink deallocate the memory or not? And, for optimization reasons, this person had, like, this was a very important question for him, but he just couldn't find it in the standard. Like, is it something that is enforced or not? And apparently here you have a separate function that says clear and free, or clear retaining capacity. Yes, there it is. It's obvious what it is. Add one, add many as array. Okay, but yeah, what is actually remove? Remove, does it remove or erase? It doesn't have that. Pop. Move to unmanaged. What the hell is move to unmanaged? Initializes an array list unmanaged with the items and capacity. Enters this array list. Interesting. Unmanaged array list. I don't know what that is, because Zig is not managed language, right? It manages its own memory. I don't know exactly what is remove single element by squashing the whole thing. Shrink and free, swap remove. Interesting. Add many as array. Definitely not add. Clear, definitely not clear. Expand. It's not insert. I would expect it's called remove or erase or something like that. I don't know. Does it have it? Zig, array list, remove. Array list remove, that removes fields down to fill the next space. That's not really advisable for a lot of use cases. Awkward sounding name. It is an awkward sounding name to remove fields down to fill the empty space. Ordered remove. Ordered remove. Wait a minute. Does that exist? Yeah, oh, it does. I missed it. I completely missed it. So that is it. This is the ordered remove, right? So if you remove this one, does it actually give you back? Yes, you need to append again. There we go. Yeah. So we have removed the first element, and then it's like it reorders everything, right? Because it moves things. And it says here, remove the element at index 1, shifts element after index I, forward, this is another one, this is I. And return the remove elements, asserts the array has at least one item, invalidates pointers, blah, 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 blah. This prevents, what does it say? This prevents item order, preserves item order, use swap remove if order preservation is not important. Yeah, so this is pretty cool. It's pretty cool that it has a swap remove as a built-in thing. Okay, so that is about, but here is one thing that happened here. We have forgot to deallocate the list at the end, and Zig does not have RAII, so it doesn't have destructors, which means that it doesn't automatically remove things. Okay, that's maybe the next thing that I want to talk about. Yes. So, I talked about allocators. I didn't actually show most of the cool allocators. Pop. No, pop only removes the last element. So if I say pop, it will only remove the last element. And I think it also takes the T, yeah. So if I do this, it will finish up with only the last element. Wait a minute. Oh yeah, swap remove because it removed the first we swapped. If I don't do that, it will have 3, 4, and 9. Yeah, there it is. So yeah, it only removes the last the last element, pop. Okay. Anyway, so there is one problem here, and that is that, so an array list is a generic struct, like, right? And in Zig there are no constructors and no destructors. So how does it work? Well, it works by, if I have my struct, I need to have all the values, basically like all the values like this, right? We have some value, some number value. Oh, sorry, I completely forgot to make it a struct because the syntax is a little bit weird, and I'm still getting used to it. So yeah, the fact that you have these anonymous structs that you give a name to, right? That's the Zig way. Give me a moment just to open a window. It's getting pretty hot inside here. Okay. So, what happens if you want to do something funky, right? Because here you can only define the defaults, like a certain number, or if it's a const u8, a const u8 means it's a string, then I can say default. But this is going to be going to be a statically, like a string literal that is saved into memory permanently, and yeah, so this string is so what it is that I mean it's just like a pointer to the text, right? Let's call it a text instead, because to make it more meaningful. Okay, so a number in the text, and now when we take we take the struct, we can say, oh yeah, I have some struct which is of type my struct, and I have a pointer, and then sorry, not a pointer, but I get I initialize it like this, and this makes it default, and then I can just do a log info, and then I can say struct. I don't know, let's call it text is gonna be a s, and I say str text, right? Something like this. Let's put a number as well, num and str number and text. Okay, so this is going to output. What is it going to output? Where is the output? What is going to what's happening here? Where did my sidebar disappear? Interesting. Debug console. The sidebar disappeared. There used to be. There it is. There it is. String number text. Okay. Let's see. Log info. No detours. Let's call it like this. And let's do one more line, one more empty line. Give me a moment, just. Okay. Okay, I'm back. Okay, so as we can see, it's a default text, and I can set it. The only way I can set it is like, you can have something else like this. And okay. Whoops. No. I didn't want to do that. I wanted to do a build, switch into it. There it is, something else. But okay, what if I want to actually initialize the struct there is something that is called a what if I want to have some kind of a constructor and destructor? Let's say that I'm actually allocating a memory in my struct, right? And I want to clean it up later. Well, in Zig, there are no constructors and destructors, so you can't use a concept of RAII, resource acquisition is initialization, like in C++, where you allocate a thing and then it magically allocates a constructor and magically disappears in destructor. But what you can do, and what is like a convention, is to use init and dinit functions inside your structs. So they say that these are not methods, but they call them scoped functions, which is a little bit weird. But yeah, you can actually so unlike C, where you can't define anything in your structs, in Zig you can actually scope. You have methods. They're not methods, they're scoped functions, right? They're inside your struct. So you can use a struct as a sort of a namespace. That's one way to put it. But you can also use it to get a self of a struct. So it's an interesting concept where the self is actually inferred. So you can grab a self like this. I have a little snippet for it though, but you would write it as const self equals this. This is not required, but it is a convention to do it like this. So this means that you get a type, right? You get a type where you're enclosed in. So this is the my struct. And the thing is that if you have a function that takes a struct, let's say I want to have an output, right? Let's call this log, for example. I want to log what's inside. And this is going to definitely be a void return type, because I'm not going to return anything. But if I take a self like this, okay, actually this should be capital self because it's a type. If I take a self as the first parameter, right, it is actually going to be inferred when I call it as a first parameter. And now what I can do is I can take this info that I have here, I'm going to put it in here, and instead of stir, I'm going to call self number, and here I'm going to say self.text. There it is. So it's going to output me with this log. So what happens here, right, what is interesting in this case is that I can remove this, but I have a stir, and I say stir.log, and you can see that the first parameter is a self. But if I actually use it, you see that it's empty, right? And I can actually use it as a dot syntax, dot log. And it's empty because if the first parameter is a self, then it can be emitted. It can be omitted, not emitted. So if I run this now, I'm going to get the exact same thing, but I've moved it into the struct, right? And this is how you can make methods inside your Zig code, inside your structs. But here's the thing. This is no different. Writing this is no different than writing myStruct.log and then providing a value like this. So if I call it now, you can see that these two are exactly the same. These two are exactly the same. So you can pass it. This is like, so yeah, you can pass it as like a static function, sort of. But you can, if you call it on the object itself, on the instance itself, the self is going to be inferred. And this is pretty cool because with a very simple language feature, you kind of solve a lot of problems. And one thing is that this is how you could initialize your values if you want to have some kind of a weird, funky initialization process. Let's say that I want to calculate something. I don't know. Oh, sorry. Let's say that typically you add an init function, and I might say, I don't know, let's pass in, well, first I'm going to have a self. I'm going to have a self. Whoops. I'm going to sell a self, and I'm going to say, I don't know, what is this going to be? Let's say, what could I do with a number to make it different or something? Init with I don't know, number to double or something, right? And something. It's a stupid example, but yeah, it makes sense later, right? Because you might do some kind of a check here, right? You want to init it, but you want to say also like if number to double is odd or something, right? If number to double 2 is 0, right? Then it will like return an error or something. So maybe you can have like a void. Yeah, with an error, and you can, in this case, let's use an error from this thing. Let's do a division. No, let's define an error as well, because defining new errors is okay. I can say const error here. Const error is error, and I can say not a double number, not an even a number, something like that. I mean, it doesn't make any sense, but let's say that this is my error, and what I can do here is I can say, okay, return me a not an even number, not even a number, not an even number. And instead of this, right, I don't need to return an error. I can say that self. Oh, this is what is interesting, right? Because like all the parameters in Zig are actually constant. This is immutable. If I want to make it mutable, I need to pass as a pointer, of course. And now I can dereference and I can change a number, and I'm going to say number. Oh, you know what? This would make more sense. Number to half, right? Because then I need an even number, right? Wait. No, this should be a 1, not a 0. And then I'm going to say number to half 2 or something like that, right? It is a bit weird, but there it is. So I init. And now when I create my thing, I can say init, and I can say number to half 12. But because it returns an error, I need to try init. And then I can log and do, right? And so the number is going to become, there is a problem. What does it say? Number to have remainder division with i32 and comp time int. Okay, yes, because it assigned integers and floats must be rem or mod. Okay. So there is another cool Zig feature. It doesn't, if it's signed value, as we can see, pretty cool. I didn't know about that, by the way. If it's a signed value, what is a modulus, right? What is a mod? Because it doesn't actually allow you to use a remainder on a signed value, right? So I guess we need to use a mod or something. Mod numerator denominator. I guess numerator is. I never heard the word numerator. So I guess it's this, right? I need to use a mod instead. Division with i32 and comp time int signed integers must use div trunc div floor. Okay, let's turn this into an I32, just to make sure that these two are, you know. Okay, what does it say now? Say division with I32 and comp time int. Okay, so it still complains. It is the division is actually the problem. Must use div trunc, div floor, or div exact. So it doesn't allow me to use a comp time int as a division. What if I as I32 here as well? So this is a casting in Zig, by the way, by using a at sign integer must use. Okay, so it does actually prevent me to use a sign integer. Interesting. How did it actually work in the... Oh, because it was a float. Yeah. So I need to use a... Okay, let's do a div trunc. Number to have, denominator 2. Does this work? Finally. Okay, there it is. We have divided 12. So yeah, what happens if we try 13? Error. The following command exited. Try not an even number. There it is. We have an error. Cool. So this is how you can like init a struct, right? Instead of using constructors and destructors. But here's the thing. What if I want to do something in a destructor, right? Well, this is how destructors work basically in Zig, is that you have a function that you call dinit. This is just a convention. You can call it destroy or whatever, release, right? Whatever you want. But in Zig, the convention is to call it dinit. And one thing is that when you init things, the rule is to never have an error, because deinitializing things should never error. So we're just going to have a void. Of course, these are all conventions, and I guess you can break it. But it's nice to use the conventions, because then we don't have to think about and waste time thinking. Okay, and yeah, let's say that, I don't know, I want to make the number 0. It doesn't make any sense, because you don't really, there's not really a reason to do this, because it would only make sense if I'm deinitting something, if I'm deinitializing, if I am deallocating a memory or something, right? That's where it would make sense to use dinit. But yeah, this is just an example. So yeah, let's say that I'm changing my number to 0 or something, right? Well, here's the thing, right? If I say here at the end, I can do dinit, right? But here's the thing. This is going to be run after everything. So what if this fails, right? What if my init fails? The init is never going to be called. Yeah, so Zig introduces a defer, and defer keyword is not a new thing. There's now a couple of languages that use defer, but basically you can, right after you initialize, you can say defer the init, and what it will do is that it will run everything after the scope. So what this does is that it literally just runs this on the end of the scope like this. And if there is an error in between, it will still run. This is really, really cool, because it will still run even if it got... so yeah, the one thing where you would use this is opening a file, right? You have like file open, and then what you want to do is you want to close a file after you use it. But you say, okay, I'm using a file here, but if this fails, it's never going to close. So what you do is you instead put the using later, and then before this you say defer close. So it will make sure that it closes even if there is an error in between. So it's an alternative to like you know, try catch things, right? Try catch blocks in C++, and you know, it works in a different way. So that's pretty cool. And one more thing is that defer will always run in a sequence opposite from when it was defined. So if you put a defer afterwards, like this is going to actually run first, file close, and then there's gonna, and then stir init is going to run like this, right? So that's also pretty cool, because if you're nesting these defers, yeah, it's kind of like you're nesting defers, right? You make sure that defers are going to run in a correct order, which is always a problem. I remember in my engine, I have this thing where I'm like calling destructors of all the engine stuff, and I need to remember, like, oh shit, did I allocate a window first, or did I allocate an OpenGL context? I can't remember, and then I have to make sure that they all run in the correct sequence. So yeah, Zig makes sure that this doesn't happen with defer keyword, right? If you just defer the init in the beginning. So yeah, here is what we made a mistake. Going back to our list, our array list, we actually didn't deallocate this. We made a memory leak because list never deallocates. Well, list actually has a deinit. So you deinit the list, but you need to defer deinitting the list. So now we make sure that at the end of the scope, which is exactly here, this is where list gets deinitted. Right. Because it was called with a defer. So this in the page allocator, we don't see any difference, but there are other allocators. We're going back to so yeah, I showed you how constructors and destructors can work. Let's remove the file because it doesn't do anything. Let's just test if everything works. No. Not an even number, right, because we were passing a to 13 there. Okay, let's do it like this. Okay, it doesn't throw errors. Cool. Okay, so yeah, it doesn't throw errors, and we have actually fixed. But here's the thing, in this case, because we were using a page allocator, it doesn't tell us at all if we have a memory leak or not. Well, in this case, we have a memory leak, and we just can hope that this is going to work. Well, there are actually better allocators out there that will actually tell us if our memory has leaked. And they're going to tell us in debug, which is pretty cool, which is something that I want to talk about now. And yeah, I've showed that there are no ctors and detors, but there's defer. But I want to also talk a little bit about our friend, the GPA, or general purpose allocator. Informs, yeah, it tracks memory leaks. So here it is. The general purpose allocator is actually like the allocator that can be configured completely, like to your will. Like, what do you actually want to use it for? Oh yeah, one more thing that I wanted to show is a fixed buffer allocator. So let me just quickly show you the fixed buffer allocator. Fixed buffer allocator, what it does is that it doesn't have anything. Oh yeah, you provide a buffer. You provide a buffer to it, and yeah, you provide a U8 buffer. So what it does is that fixed buffer allocator, you can have it on the stack. So if I just say, okay, let's do a var buffer, and I have, I don't know, there is, let's do a 64 bytes of undefined memory, and I'm going to provide it with a U8 with the buffer, but it's going to be a pointer to the buffer. And there it is. We have a little fixed buffer allocator. And the fixed buffer allocator does not need to be deinitialized, right? Because it's on the stack. And the cool thing is that we can have a list now. We can make an array list which has std array list. Yeah, i32. Let's go with an i32. And I'm going to init with my fixed buffer allocator. And of course, I need to make sure that the no, I didn't actually want to have a block. I wanted to say the init. There it is. And oh, what is going on here? It's not an allocator. I got a fixed buffer. Okay, I think I need to get the allocator. Yeah, this is it. Okay, so I'm gonna append a few numbers, right? Let's see if it works. List append, I don't know, 67, whatever, and then do a for loop for of list items, value, log info, fixed buffer, list value is gonna be value. Okay, let's see if this works. Error is ignored. Yes, of course. I always forget that you need to try append because it can fail. There it is. We have a fixed buffer list. And here is the cool thing, right? This is not possible to do in C++. You have a list. We have basically a vector that is allocated on the stack. For this, you would need to have like a custom type or something where I actually have one myself. I made it in C++ to have like a fixed array, as I call it, which can actually expand and contract and have basically an allocator. So this is cool that we can mix and match different allocators for your lists, for example. So you can provide it a fixed buffer, which is a stack allocator. Cool. So yeah, there it is. And this allocator is actually automatically deinit. You know, I think I don't need actually to deinit the list. Yeah, it doesn't actually complain. Well, I don't need to deinit the list because, you know, the list, the allocator is just, you know, it disappears when it goes out of scope. And the cool thing is that, I mean, I would need to deinit if I was using allocator for something else. So I could do like this, right? If I had a scope and then this would be called at the end of the scope, but I can use this alloc to like allocate something different, right? I can do another, what is it? What's the name of it? Create, yeah, create. And then we can do an i32 and I grab a pointer to it, right? For example, I'm not going to do that, but yeah, this is how you can like reuse the same allocator. And in this case, this is going to be the stack allocator. Cool. So yeah, there it is. And I actually showed you in a short time, I showed the fixed buffer allocator. And yeah, let's go onto the GPA and let's redo everything basically. But instead, I'm going to make a fixed buffer. Basically, we have everything is the same. Everything is the same, except that for the allocator, I'm going to have a heap. What's the name of it? It's called general purpose allocator. And here we have a config. And in the config, you can pass many things. You can do safety checks, stack traces, thread safety, verbose log, whatever you want, right? It's a very, very buildable allocator, and this is all things that are done at compile time. So you will get a purpose-made compile time allocator. But by default, you can just do this. And then you do this to initialize the GPA. So I can just say, okay, my GPA is this, and then I can grab an allocator, and I can say, okay, my allocator is this, and then there we go. We have an allocator. We can init the list, and I think you can just pass the allocator like this, right? I think so, yeah. And I think that's it, except that I did not, of course, de-init anything, right? Because I have some leaked memory, and I should. So here's the thing. This should work, but it will throw an error because everything is leaking. Nothing happened. Interesting. Let me actually make sure that this runs. Log info. GPA. Okay. Yes, it does work, and it does not. Oh yeah, let's remove defer now. Oh, it actually still. Okay, interesting. Did I forget to initialize it or something? There's no init. Does this have init? No. Okay, I must be doing something weird. Because I think it should, by default, it should throw errors. Go to, no, alloc is an allocator. There definitely should be de-init. Yeah, there it is. It returns a check. It returns a check. Ah, so de-init will actually return a check. I think that this is, so if I not use it like this, there it is. Yes, I wrongfully de-initted it. Okay, so what is going on? Segmentation fault at address. There is a segmentation fault. Okay, info GPA. So what does it say? Anything? Alloc slot. It's trying to allocate something. Zig allocator interface is not intended to solve alignments beyond. Okay, interesting. Interesting errors. Failure. Interesting. Okay. So this what actually does is that it returns a leak where it leaks or okay otherwise. And you can actually catch this. And I remember that there is a way to do this somewhere. Zig general purpose allocator. General purpose allocator. There is actually somewhere there is a way how to use it correctly. But you know what? I actually have a little snippet which I'm gonna check if it's the same. General purpose de-init. I do it. Of course, it needs to defer as well. And then I get a const GPA allocator. So this doesn't need to be, this can be a const. Interesting. And this needs to be deferred so that, yeah, we check at the end and not at the beginning. Yeah, this, of course, segmentation fault, it doesn't make any sense. Why would I, like I was de-initting it at the beginning. Yeah, I'm dumb. I completely forgot about defer. Okay, so yeah, there it is. Everything works now. But if I don't de-init the list, boom, there it is. It says, look at that. Memory address leaked. Ta-da! There we go. You see, so it tracks that we have initted the allocated, so we have initialized some memory, but we have not de-initialized it. So it tracks all of it for you, which is pretty cool. So if you forget to deinitialize lists, you should pretty much use a GPA all the time. So after using the list, what I can do is I can allocate something more, right? I can create. It's funny that it uses the word create and not new, which is like, yeah, we want to use a different word than C++. So yeah, this is going to be a pointer to a something, and a pointer. Let's change the value to 10 or something, just to have some value. Create, right? It returns error, so we have to try create, of course, and then the pointer to it is the value. So if we try to run it, even if we have deferred deinitialize the list, it says memory address leaked. Yes, there is a leak, and there it is. We have created. The cool thing is it gives you where you have created it. There, we called a create, and after this, we didn't call a defer. We didn't deinitialize this. So, well, we need to destroy. There it is. Destroy a pointer, right? So I can say a pointer, and I can say defer, destroy. So now we make sure that there it is. Everything is unleaked. Everything is. Would you say sealed? Everything is sealed because anti-leak. Yeah, I guess that's how you would say. Everything is sealed. Nothing leaks. So that's pretty cool. There we go. This is all about allocators. And is that it? Is that all the cool Zig stuff that I wanted to show you? I think so. The last thing I wanted to talk about. Oh, yeah, there is a little bit more. So fixed buffer. Whoops. Fixed buffer done. GPA done. Tracks memory leaks. The last thing I wanted to talk about today, about our Lord and Savior Zig, is oh, you know what? This is actually a stream 3, like this, and this is all. I started with captures, right? There it is. Go over a few features. Yeah, so it should be more like this. And there's only 2 left. Cool. Arbitrary size ints, no operator overloads, vectors, mathematical. Yeah, so I wanted to say that Zig does not have operator overloads. And this is something that's going to enrage probably a lot of game developers. Because you might think, wait, one side, not having weird operators is nice, because like C++ has all these like cout, what the hell, this kind of a thing, which is very specific, and then you have all these like time plus, you have like those like minutes plus. Oh, what is happening? Oh, I'm completely missing to put plus. Minutes plus seconds plus that, right? You can really bend operators to your will, right? If you open like, yeah, recently I found GLM vec3 or something like that. Where's let's see, GitHub. GLM vec3. Okay, let's see. No, wait. Where is vec3? GLM. I think it's an X matrix. Let's go to like a vector 3. Flow 3. Flow 3? I think detail type vec3. There it is. Detail type vec3. Let's look at it. Okay. Yeah. First off, it's chaos. So many pragmas. What the hell? Pragma, clang. Ah, what? Okay, I've never seen this. I've never seen this before. That it's written like hashtag pragma later. This is really bending C++ formatting. This is why Zig is also nice. You know, Zig just is like, you know what? We just automatically format everything and don't waste energy on doing some weird formatting like this thing, because I'm like reading this and I'm like, what the hell is this? Is this some kind of a macro? But no, it's actually hashtag pragma. It's just all the way here. And endif as well. My god. My god, it's glorious. It's glorious. But yeah, what I wanted to actually show you here is the chaos that is operator overloads. Look at those operator overloads. Aren't they beautiful? Aren't they beautiful? Look at this. Look at this. Operator minus, operator plus. So many minuses and pluses. I guess it all depends on whether something is const, whether something is a reference, a pointer, whatever. Oh, there's also scalars. Multiply. But what is multiply? Is vector two vectors? Is it like... does it mean dot product, or does it mean member-wise multiplication? You have no idea. You have no idea. And yeah, then there is a percent and I don't know. Is this a bitcast? I have no idea what it is. What is this? And this, I guess that's kind of a bitcast or something. And then you have this, which is, I don't know, maybe it's for formatting. And then you have a tilde. Maybe that's just flipping the bits. I don't know. It is, yeah, and it has all this like, okay, this is AND, obviously. But why would two vectors end each other? It's kind of a weird thing, right? Yeah, anyway, what I'm trying to say is that operators are magic. In Zig, there's no operator overloads. Nope. There's only... The only thing you can do is you can add numbers like this. You can, you know, you have division, you have minus, multiply and stuff. And that's it. Everything else, if you want to do a dot product, you would need to do a function, right? You would have some kind of a struct, for example. Let's remove this. Like you have a... If you have a vector, right, and you want to do a dot product, you would do like a function, right? Let's do a self and do a fnself, because I have this, and you do a dot, and you say you could do like pass in another vector, right? Other, let's call it other vec3, and you say, okay, self dot whatever. What's there? Const x, no, x f32, y f32, and then you can do a self x by other x plus self y by other y, right? This is the this is the product, if I remember correctly, the dot product. Yeah, and then you can create a vector. Let's actually call it with a capital V. And other is also a self type. Whoops, a self. So yeah, basically, if you have a vector, let's call it vector1, and you create a vector, right? Let's do x is 1, y is 2, something like this. And then you have another vector. I'm just gonna make it a vec1. I copy the same one. And then you just do a vec2. There's no multiply. Well, okay, there is, but it's a secret for now. And you have another vector which is like an, because I didn't overload, right? There's no way to overload a vector. Instead, I need to use a vec1 dot vec2, for example. And there we go. We have now the dot product. And this is actually going to be a float. This is not a dot product. Something like this, right? And then we can say dot product is dot product. Let's actually add this into a separate scope and call it no overloads. Okay. But does that mean that we need to add all the plus, minus? Well, here's the catch, right? It does. It's true that Zig doesn't have any operator overloads, but here's a cool thing. If you're following, if you're still awake, I'm almost falling asleep. But here's the thing. The next thing that I'm going to talk about, right? It doesn't have no operator overloads, but it has vectors. And vectors behave kind of like normal values. So if you have an A, which is I32, how many times have I written this? You have a 2, which is also I32. Let's do a const because I'm not going to change them. And, well, I don't want to save. And I'm going to do like sum, right? The sum is A plus B. Okay, so it's a simple type. Where is again my there it is. Okay, sum is 25. Okay, of course, 12 plus 13. Okay, so it's a simple type. It's a simple number type. It can be added. And if we use an F32, it can also add onto a F32. Actually, what happens? Yeah, and but with that we need to use a D2 to make it a little bit prettier. Actually, I'm thinking about now, what happens if this is an F64? Aha, it does actually, I think, coerce into an F, if it widens into an F64. Yeah, let's not do this. Let's do A plus B. Like this. And I'm gonna do, I'll put the C and type of C to see what the C is. There it is. The type of C is actually F64. Yeah, so it will always widen if you add F32 to, okay. Well, it doesn't, it's called, yeah, it's a topic in Zig and it's called peer type resolution, right? If you're trying to add things and, you know, passing into functions and stuff. There are rules. There are strict rules, right? It's not random, it's very strict. Okay, so introducing vectors. Vectors are basically like fixed dimensional types of the same thing. So the difference between an array and a vector is that the vector is actually automatically simplified, and it will have the alignment of the of like the whole thing. So if I'm not mistaken. So let's say that you have a vector, and the way that you create a vector is you say at, because it's a built-in vector. The length is, let's do a 3, and the element is type F32. Let's do it like this. And now we have a vector that is this type, right? But creates vectors. It says creates vectors. Nice. And it has, oh, look at that. It actually has a link to vectors. And what happens here is that we can initialize it with a syntax like this. I think so. Yeah, we can. And if I have another vector, let this be vector 1, right? Well, let's do a const again. Vector 3 F32, same thing. And I don't know, let's do 3, 2, 1 just for fun. Okay. And here's a cool thing. The cool thing is that operator overloads are not allowed, but you can actually add vectors. You can have, let's do a third vector. Result vec is vec1 plus vec2. Log info result vec, and then I can output the vector, and I think it will automatically format, if I'm not mistaken. There it is. It will automatically format, and we have two vectors which we add. 4, 4, 4 is the result because it's component-wise plussed. And the cool thing is that, this is SIMD-ified. Like, this is actually going to be compiled into a single data. SIMD means single instruction, multiple data. This will be put into a single register and added with vector 2. So this is why, like, the special mathematical vectors are cool. And this is how you can do 3D calculations and whatnot, right? And you can provide it with whatever number you want, right? You could have a 6-sized vectors if you want, or a 2-sized or a 4-sized vectors, right? And another thing that you can do is you can also multiply, and this is going to be a component-wise multiplication, of course, because it's always, with vectors, it's always component-wise. And as you can see here, it is 3, 4, 3. Another thing is that we can use the same formatting rules as with floats. So if I just put this, it will write 3, 0, 4, 3, 4, 3. Let's put a 1 decimal actually to make it even prettier. There it is. It's a little bit more concise. Hello Vafig, nice to see you. Hello again. What is the dot whatever syntax? Dot is a tuple. So what it is like an anonymous struct, right? It's basically like if you have something, then you can put and the thing is that you can put anything inside it, right? It can be a text, can be, and then you can use it for different things. But in this case, so what it means is that, it doesn't need to be, the items don't need to be named. When the items are not named, then it's called a tuple. You can actually name things, I think, like this as well. Yeah. But yeah, it totally works. So here's the thing. Struct, it's the same thing. A struct and a dot is basically the same thing. What it means is that just create a type on the fly, right? So info takes a tuple instead of having variable arguments for. Yeah, exactly. So because in Zig there are no variable arguments. You always have a fixed number of arguments. Because that simplifies function overloads a whole lot. It makes the compiler much faster because it doesn't need to think about function overloads. But what this does is that I actually showed this in the first stream, how it works. So how it works is that this is like, you provided a tuple. So if I had something else here, I had just a number, I don't know, something like this, you would add it as an argument. So you give it an arbitrary argument, but what it does is that the info function is actually compile time. So as you can see here, info takes in any type. So this any type can be, in this case, it's a tuple. But what it does under the hood is that it actually loops through the fields of the arguments of the argument tuple. Basically, it's a tuple. And then it checks which type it is. If it is an integer, it will output an integer. If it is a string, it will output a string, and so on and so on. So that's how it basically looks. So how it actually works. So yeah, you could make your own info this way, right? By just checking the type of whatever you're taking. It's receiving. Yeah. So, yeah, another thing I think you're making me think now. If a function receives a struct, okay, let me try something. Okay, one more thing. Const struct to take. Wait, I don't need to do this. Oh yeah, I have to do it. Struct to pass into function. Beautiful. Beautiful name. I have an AI32, BI32, whatever. I have two I32s. And I have some function that takes in fun with struct. Like this. Fun with struct. Yeah, great. And I have some struct, and it's going to be of type this. But I'm not going to return. Yeah. I'm just going to like log info. And oh yeah, this won't work actually. Interesting. Yeah, I don't think you can actually pass an anonymous. Can you take a first element of a struct? I don't think so. Let's try it. What's the name of it? Fun with struct. Okay, and I'm gonna provide it. What if I provide it with an empty struct? Struct declared here. What? Missing struct field A. Aha, it needs to have a... Okay, but I can do it like this, right? No. Aha, it does not support indexing. So it does actually work, it just doesn't support it. Okay, so it needs to have names. It needs to have the same names. Yeah, interesting. There it is. So it actually works. I don't need to name the yeah, it actually infers that this is the struct type. Cool. That is cool. But what if I don't... Can you have a struct without names? like this. Aha. Struct declared here. There is a problem. Okay. Ah, I remember now. This is how it works. This is how you read a tuple. Struct declare here. No field named A instruct. Where is that? Fun with struct. Fun with struct. Okay. What if I do it like this? Okay, it works. So this is how interesting. So a struct doesn't need to have names. Okay, so struct is actually exactly the same as tuple. Now I see. Interesting. Okay, this is really interesting. So this is exactly the same as a struct. No, it's not. It's not the same. Expected type found struct. Comtime type 32. Interesting. So it is actually a if this was an any type, it would work. Yeah. Okay, so the struct actually ensures that it is named and that it can be passed into functions like this. Yeah, I am actually a bit confused about the differences between tuple and a struct. Because apparently you can also define a struct with a dot syntax. Apologies, I would never want to make anyone think what a burden. Yeah. So apparently you can do it like this. But what if I say struct? Huh? What if I say struct here? No. Explicit type. Struct found type. So a type, a struct is a type. And this is not a type. This is an instance. So maybe that's the difference. It makes sense now. It makes sense. Because struct is a type. This defines a type of struct to pass into function. And if I just put it here, then it's an instance that, but this doesn't make any sense then, because I have two types. Okay, maybe this is just because it expects to be a comp time type thing. Yes, that is why. Yes, now it makes sense. Now that is why this error says expected type found comp time type i32 comp time. Yeah, because the members are actually types. Okay, yeah, it makes sense. It makes sense. So what the dot basically means, basically means this is an instance of like an inferred tuple or a struct. So it can have named fields if you want, but it doesn't need to have named fields. Yeah, I see now. So can you actually have a thing which is just an unknown thing, but with numbers, like this? Well, you need to have a dot as well to signify it comes from inside. There it is, it can. It does actually work, yeah. So you can actually create a dot, an instance of a struct, which has values with the named fields, basically. Yeah. But yeah, if I made it a struct, then this would be a type. The thing would be a type and not an instance. Yeah, that totally makes sense. Yeah, and the reason why they chose it, yeah, I remember there was actually a discussion on the issues of Zig. There was a discussion like, why does the dot exist? Why is it not just this? The problem with this is that because this is a void type, so this is how you actually define a void. So if you have a void, then this is a void, like this, without a dot, and it's also a block, as you can see here, right? So yeah, that's why we have a dot. And you know, I don't mind it, but when you see the Zig code for the first time in the wild, because usually the first thing you see is a hello world, you know, and the hello world looks like this. You have like I don't know, something like this. Hello world, and you are like, wait, it should be like this, maybe. And then you're like, wait a minute, what the fuck is going on here? Like, why is this? What? Why is there a dot? It doesn't. What? I remember the first time I saw it, but then I realized pretty soon that this is just a list of arguments, and yeah, this means that it's a tuple, which can be any type. It is cool when you understand it, and then you're like, this is pretty cool, but it takes some time. So it's like C struct int A B. I think so. Yes. Yeah. Exactly. Yeah, it's true. That's it. You are correct. Okay. So, and by the way, yes, the reason why I also need to explain why I knew that this is the fact. So here's the thing, right? In Zig, you can't have names that start with number. Of course, just like in any other language. But you can have a name with a number if you name it like this. There it is. It actually works, I think. Variable of time counting must be constant. Yeah, this is not. This is an unrelated thing. Yeah, let's just make it an I32. But I'm just showing that it's, you know, this is not an error. This is how you name the zero variable. And the thing is that your tuple members actually go 0, 1, 2, 3. And the way you get them is by grabbing a number. But you can't grab a number because, you know, this doesn't work. You can't do like this, dot 0. So you have to use this wrapper of zeros. And this is actually mentioned in the documentation. I didn't just invent this from the top of my head, because I was reading this in the documentation and I was like, this is weird, but okay. I can live with that. I mean, the thing is that I don't know if I'm ever gonna use this kind of a thing, like unknown field members, because you always have some kind of a struct that have a known type. Yeah, unless you're passing them into an info. So anyway, yes, talking of vectors, going back to vectors, right? You have a special syntax, then you can make it into a vector, which is cool. And of course, if you want to make it more shader-like or struct-like, you can always cast it. If you can always alias a type like this, right? You can say 3F32. So now I don't have to write this thing. I can just do this. And there you go. It totally works. It totally behaves the same as well. There you go. Yeah, what happens? Now I'm wondering ahead of time again. Vec3 what if I have what if I have a longer vector? Is it going to work? I doubt. There it is. It's an error. Mixed scalar and vector operands. Vector 3 and type. Okay, this is a type. How is it a type? It is a type because I didn't initialize it. This is not a type. Any problems now? Yes. Vector length mismatch. So yes, you can't do that. Length 3 here, length 4 here. Nice. Nice that it shows where each thing is. Yeah, so you can't have two mismatches, obviously. Okay, one more thing I wanted to show is that there is a way how to initialize vectors with the same value. So if you have a vec4, you can do a splat. There's a way to make it a splat, but I'm not exactly sure. Yeah, if I do it, can I do it like this with a type of vec3? And I say splat any type splat 0. Let's try this. Is it gonna work? Log info vec4 something like this, and let's do the same thing at vec4. Yeah, it works. So if I make this a 1.23, right? It is going to be 1.2. So what splat does is that it produces a vector where each element is the value scalar. The return type and thus the length of the vector is inferred. So it infers the vector, the return type, according to what you are casting it into. And as you can see, it will make all the dimensions the same. There are also similar things that you can use. Splat scalar expect memory equal as u32. So yeah, you can also cast it. You can also cast vectors into arrays, as you can see. Yeah, let's not look at GLM anymore. Oh my god, these operators. The number of operators they overload, it's crazy. Okay, let's take a look at vectors. I think that there are some cooler things as well. A vector is a group of booleans, integers, floats, or pointers, which are operated in parallel using SIMD instructions if possible. You can create them with vector. Vector supports the same built-in operators as their underlying base type. Performed element-wise, return vector of the same length. Arithmetic, div floor. Oh, you can do all these things. You can use the div floor, square root, ceiling, and log, and other stuff that you can do with operand, other stuff. And bitwise operators as well. Comparison operators. So, yeah, nice. You can actually compare. What do you actually return? What does it actually return? What does a compare return? Does it return a bool? It's prohibited to use a math operator on a mixture of scalars. Makes sense. Zeek provides the splat built-in to easily convert from scalars to vectors. It supports reduce and array indexing syntax to convert from vectors to scalars. What does reduce do? Reduce operation. Reduce up. You can actually, I think it applies to the whole. Oh, interesting. So I think it's actually takes the whole. If I have an add. Okay, let's do like this, right? I can provide it a vec4. It probably gives you a number back, just one number. Vec reduced. Right? Let's see. Vec reduced. Yeah, it has combined all of them. 1.2, 1.2, 1.2. Nice. Okay. So if I put... Whoops. So yeah, okay. There it is. Yeah, it gives me a 3. Nice. That's pretty cool. And of course, you can do other things as well. Max, min, mo. Yeah, this would be a horror to find in C or C++. But you see, enums, super easy. I just opened and I said, oh, it's an operation that is an enum. std built-in reduce. And I just go, std built-in reduce up. And it gives me all the operations. There it is. It's not a gazillion macros. And you can even get a maximum. This is probably like a single instruction as well, right? I'm pretty sure. Okay. What did an AND mean? Reduce operation AND requires integer or boolean operand, not a float. That makes sense. I was really wondering. It is prohibited to use a math operator on a mixture of scalars. Well, that is extremely inconvenient. Scaling vectors is a thing you need to do all the time. Yeah, but I think with scale, there is another thing. I think you can actually there must be a way to do vector multiplication of an entire thing. Let's see if it actually works. Scaled vec4. That's a good thing that you mentioned it. So if I scale it by, I'm used to. Okay, does this work? There it is. Big scalar vector operands. Doesn't work. This doesn't work, but there must be a way to do it. For rearranging elements within and between vectors, Zig provides the shuffle and select functions. What is a select? Type, predicate. Selects values element-wise based on a predicate. If predicate I is true, corresponding element will be A and otherwise B. I see. Cool. That's probably also a single instruction. Because that sounds like a common thing to have a instruction for. Set float mode. Interesting. Okay. Multiplying a vector. Maybe there is like a scale or something. Is there? Shuffle select. It doesn't mention anything. See also. Splat, shuffle, select, reduce. I see. To do. Talk about CABI. To do. Consider suggesting std multi-array list. Okay. I haven't noticed this before. To do's. Does it say something in the... You can also assign from a slice with comp known length to a vector. Interesting. You can use the array syntax to put a slice into an array. Right, cool. That's actually really nice. But how would you multiply? With a single instruction? I don't know. I feel like there should be a way to do it. Maybe they add it in the bin time. Scale? No. Multiply. I mean, you can always add two vectors. You can always scale two vectors, right? By making a splat to... how would you cast it? Oh. What happens if I do this? Does it infer a type? No. Splat must have a known result type. Use as to provide explicit result type. So yeah, you can actually use an as vec3 like this. Yeah, there is our solution. So yeah, but well, what I do here is I just convert this into a vector 4. So, and then I multiply. That's how you do it. But I don't know. I feel like there should be a single instruction thing to do this, to multiply the whole array with a single scalar. But you can do this in a concise way. And there it is. That is quite gross, but I guess with more comp time stuff could make that less awkward. Maybe. I mean, you could make a function, right? Could use a mul, and then I can pass it an any type. And then have a scalar of f32, and then I can do the same thing. Can I do something like this? It also returns a... It should return a... How do I make it type of vec? Should be the same type. Can I actually return an any type? Yeah, that's one of the problems. You can't actually return an any type. Okay. If I return a vec multiplied by as type of vec and scalar, and then splat like this. Yeah, well, one thing is that I can't put a function inside. It doesn't have... Zig doesn't have anonymous functions, by the way, or closures, or lambdas, as you would call them. But it is a proposal to add them into... This is one of the... This is actually one of the most... one of the things that I would love to have, lambdas with captures. Okay, so let's try using a mul. Scaled vec mul scale vec 4. Something like this. Is this going to work? Okay, there it is. Well, it works. Surprisingly, it worked. So the type of vec actually worked. I thought that it's not gonna know what the vec is, but it does. So there it is. You can easily make comp time. You know, you can make a comp time function to multiply. Yeah, well, this should actually be probably called scale and not multiply. Muscale. Oh, muscale scale. Okay, something like this. But you know, maybe there is a built-in function for that already. I'm just not aware of it. Scale bn. There it is. What is this? I don't know what is bn. Binary? Skalbn. Does it have... There is a lot of things that you can use with the mem. Like, that's how you concatenate. Maybe it's possible to also scale or something. No, I don't know. Because, for example, with a mem, you can get zeros of a type. You can fill an array with zeros in this way. But yeah, there you go. There you go. Okay, so that concludes everything I wanted to show. Wow, 4 hours of Rust. Rust, my god. 5 hours of Zig. 4 hours of Zig. That's enough for today. I'm too tired. Now I'm mixing up Zig and Rust. So that means my vector maths in Zig is going to be just as awkward at the call sites as it is in C. But the vector math library will be easier to write. 5 hours of zigzagging. Yeah. Zigzagging. Right. My vector libraries. Yeah, I just noticed that math Zig. Sorry, what's the name of it? Mach hex up math. Yeah, mech, and so mech engine is a it's a game engine that is being made. I just noticed today that Stephen here has added an editor. There it is. He created this 4 hours ago. A Mac editor. And yeah, it's a start. It's a start, but it takes a long time. It will take a long time, I think, for it to be usable. But yeah, they actually have a math somewhere inside here. Maybe it's in the math itself. Maybe they're going to split it. There's math. So how do they actually implement vectors? Okay. Comp time value usize comp time scalar type Return extern struct. It's an extern struct. Why is it an extern? The vector dimension size, okay. Scalar type, okay, they just call it, they just store it as a const. Underlying vector type. Okay, so there it is. It actually contains the underlying vector type. And then switch. Using namespace switch. What the hell? Okay, I'm confused. I've never seen a using... So using namespace is just used so that you don't have to alias a name. But I've never seen it used as a switch. Using namespace is a declaration that mixes all the public declarations of the operand. Must be a struct, union or opaque. Using namespace is an important use case. Okay, I've never seen a using namespace being used before a switch. What does that mean? It's weird. 5 hours of oh yeah, I read it. Okay, anyway. Returns a vector with all components set to the scalar value. Yeah, this is the same as plotting. It's just a length faster than len. Oh, yeah, of course, because it's squared. Computes the length of the vector. Yeah, this is all the stuff that you really want. GPU compatibility. Oh yeah, these are all the tests. Is it actually self-contained? Import std, import main zig. Oh no, it does actually import mach. It would be nice to be separate so that I can use it on my own. What does it do with mach? It doesn't do anything. Oh, it's only mach testing math. I see. It just references other stuff. Math is hard enough as is. Nice. Yeah, it actually aliases in the same way that I'm doing it. I'm aliasing vectors and yeah, cool. Yeah, so you can maybe just use this one instead, but it would be nice if it existed separately from the engine. Add more tests. Yeah. It doesn't have math as a separate thing. Okay. So yeah, I think that this is pretty much it. I've showed you around. I even showed you some C stuff. I can delete this. And I've finalized everything about Zig, which is great. So on the next stream, I can start making my engine and start making a new engine. Well, what I want to do actually is I want to go over my actual engine and then kind of explain how I want to build my new engine in Zig in a very similar way, actually. And yeah, I'm thinking about, should I do architecture first or should I just draw a triangle first? Maybe I should draw a triangle first. Draw a triangle just so that I can make sure that it works, that everything works. And for that, I'm actually going to use one of these, which is there's a sample. Yeah, MachCore starter project is actually great, but I'm not going to use that. I don't want to use MachCore. I actually want to use GLFW, just in the same way that I'm using. There it is. This one. So GLFW. These are really good bindings. So you just need to include this. It should download it for you automatically using the package manager. And because it has a ZigZon file. The ZigZon is the package manager file. And yeah, it actually, there is somewhere here, there is actually a sample project. Mach GLFW sample. Example for using Mach GL. There is somewhere here. Example for using Mach GLFW. Yes, this is it. Mach GLF OpenGLW. Yeah. So this one, it is a little bit older, but it is actually, I remember that somebody has fixed the errors for newer versions. So basically this will make it, make a window, and that will allow us to draw our first triangle. And I tried to build it once and it worked, so I think yeah, there it is. You can see that some people have fixed the updates, the update dependencies, update build Zig. Yeah, it was actually this one, I think, which I used. So yeah, for the next time, for the next stream, I am going to include this and start drawing some triangles. Nice magenta. Yeah, it's I don't know, how would you call this? Lila? No, it's like between violet and rose. It's not really magenta. Anyway, yes. Well, thanks you for joining. Thank you for joining. I showed quite a bit of Zig. Oh my god, we wrote 300 lines of code, 320. That's not enough. And I showed you a bunch of stuff, arrays, pointers to for loops, multi-object for loops, optionals. Yeah, or else, the weird or else keyword. Pointers, and then C pointers as well, and single multi-array pointers that you can get a index to, like a C pointer, and the reference as well. And then you have these nodes which show the optionals, how I implemented a optional pointers. And then I showed you errors. Oh, there's heat warning. Okay, cool. Thank you. Optionals and errors. So number error, yeah, returning an error using a try, unpacking. Oh, did I actually show that you can use an if as well? I didn't. But yeah, you can actually use an if with an error as well, and then capture it, similar to how you can do it with optionals, like this. And you can also while. So while it's not an error, do something, and else throw an error. You can do exactly the same things as you can with optionals. You can do with errors, but yeah, it's slightly different in that you use a try keyword. In optionals, you actually use a like this kind of dot question mark syntax, or else, if you want to catch. Oh yeah, I totally forgot to say about catch as well, because you can also use the catch keyword. Oh my god, I totally forgot about the catch keyword. Yeah, so you can actually handle the error with a catch. So if you have with something with error, you can catch it and take and provide a different value like this. And another way that you can handle the errors is with catch switch. So you can catch switch. You can grab an error and then switch on the error, and then you say, okay, if my error is number error, do something. I didn't actually talk about switches at all, which is another cool feature, because Zig has exhaustive switches, similar to how it works in Rust, right? You cannot have, you need to cover all the cases. You cannot have, and it doesn't break. You don't need to, it doesn't fall through like in C and C++, which is great. But yeah, this is how you do it. This is how you do stuff. Yeah, so there's a few more things I didn't mention, but they're not very important in my, I think so. So yeah, that's it. I think with these things, oh yeah, I showed you the allocators. I showed you allocators, a simple page allocator, and then yeah, I made an array list, swap removed, popped, and then I made what is this? Oh yeah, I was showing that there's no constructors and destructors by creating a struct that has init and dinit. And yeah, and then I showed you the fixed buffer allocator, which is a stack-based allocator, and then a general purpose allocator, which is pretty cool because it tracks leaks. Yeah, cool. So that is it, and no operator overloads and vectors at the end. So that's about it for this kind of intro to Zig series. And I think that I basically went over most of the language. That is most of the language, I think. If you go through this reference, you can find most of the things. Hello world, it explains all about the hello world. Comments, oh yeah, comments can also only be in this, like there's no multiple line comments. Different values, I went over that in the beginning. There's a list of values. Assignment, testing. We didn't use tests a lot, but they exist and they're pretty cool. I actually showed them at the beginning. Memory leaks with a testing allocator. Variables. What else? Local variables, integers. Yeah, there's a lot of different coercion like rules and stuff that you can read about. And they're really easy like to understand, unlike C++. Floating point, okay, different operators, table of operators. Oh yeah, you have these like, you also have like wrapping and non-wrapping operators. Yeah, there is a catch error for union types. Yeah. Vectors, I talked about them pointers. Talked about them today. Volatile, I didn't mention. It's not really important unless you're doing embedded. Alignment is automatic with allocators, so not really something that I need to think about. Allow 0. I can't remember this. Optional pointers. Oh yeah, this is something with interfacing with C again. Slices, talked about them. Packed structs and structs. Struct naming, tuples, I mentioned them. Enums, they're super easy. Unions are just like C++ unions. Tagged unions. I didn't actually talk about tagged unions. Or did I? I can't remember. I didn't. Oh my god. Well, that's pretty cool. But yeah, read about them. I'm not going to show them. But basically, that's like a union that knows what type it is allocated. So it's like having like a enum type. Imagine that you have like an enum provided with it that has type information. That's basically it. It's a union with the type information, and you can switch through it with different or loop through it with different types, which is pretty cool. It's like a way how to do polymorphism without vtables, which is pretty cool. Packed unions. Opaque is for interfacing with C again. Blocks, how blocks work. Shadowing is not allowed. That's easy. Exhaustive switching, I mentioned that in the end. Inline labeled while. Yeah, I didn't show you that you can label everything. You can label loops. So that's the way how you can break. Yeah, like continue in the outer and break. So without using gotos, which is unsafe. For loops. Defer. Unreachable. Yeah, unreachable is used when something, it's like an optimization thing. Compile time, functions. Catch, try. Used for errors. Defer. Inferred error sets. Yeah, this is about error sets that I was mentioning today. Casting, different types. Using namespace. Yeah, I mentioned it today. Recently. Data structures. Print in Zig. Atomics. I didn't mention atomics, but I'm not gonna use them at all. Probably. Add with overflow, yeah, you have, oh yeah, and then you have a huge list of built-in functions, which is like, you know, all for arithmetic, for atomics, for casting stuff, yeah. And there's a huge list there. Memcopy, blah blah blah. Everything that's not part of everything that's kind of like a language embedded thing. What is this? Truncate. Okay, truncating. Types. Building. Yeah, and then there's building. And that's basically it. So yeah, I kind of went over the whole thing, except atomics. Except mutexes and stuff like that. Which is for parallelism. Source files seem interacting with C. That's another topic that I don't need to do. Okay, so that's about it. This is the style guide. Nice. For space indentation names. Nice. Yeah, maybe I can do like a style guide tomorrow or something. In the next stream. And here is the entire language file. And that's it. And you have the Zen. Yeah. That is it. Thank you for watching. Hope you enjoyed. I finished with the introduction, with the Zig introduction. Next time on the Zig stream, gonna start making my engine. A very small one. Drawing a triangle. Let's start with drawing a triangle. Okay. Thank you. And see you next time.